Principles of Geology by Charles Lyell. Chapter 5. Prejudices which have retarded the progress of geology. If we reflect on the history of the progress of geology, as explained in the preceding chapters, we perceive that there have been great fluctuations of opinion respecting the nature of causes to which all former changes of the earth's surface are referable. The first observers conceived the monuments which the geologist endeavors to decipher to relate to an original state of the earth, or to a period when there were causes and activity distinct in kind and degree from those now constituting the economy of nature. These views were gradually modified, and some of them entirely abandoned in proportion as observations were multiplied and the signs of former mutations more skillfully interpreted. Many appearances, which had for a long time been regarded as indicating mysterious and extraordinary agency, were finally recognized as the necessary result of the laws now governing the material world, and the discovery of this unlooked-for conformity has at length induced some philosophers to infer that, during the ages contemplated in geology, there has never been any interruption to the agency of some uniform laws of change. The same assemblage of general causes they conceive may have been sufficient to produce, by their various combinations, the endless diversity of effects of which the shell of the earth has preserved the memorials. And, consistently with these principles, the recurrence of analogous changes is expected by them in time to come. Whether we coincide or not in this doctrine, we must admit that the gradual progress of opinion concerning the succession of phenomena in very remote areas resembles, in a singular manner, that which has accompanied the growing intelligence of every people in regard to the economy of nature in their own times. In an early state of advancement, when a great number of natural appearances are unintelligible, an eclipse, an earthquake, a flood, or the approach of a comet, with many other occurrences afterwards found to belong to the regular course of events, are regarded as prodigies. The same delusion prevails as to moral phenomena, and many of these are ascribed to their intervention of demons, ghosts, witches, and other immaterial and supernatural agents. By degrees, many of the enigmas of the moral and physical world are explained, and, instead of being due to extrinsic and irregular causes, they are found to depend on fixed and invariable laws. The philosopher at last becomes convinced of the undeviating uniformity of secondary causes, and, guided by his faith in this principle, he determines the probability of accounts transmitted to him of former occurrences, and often rejects the fabulous tales of former times on the ground of their being irreconcilable with the experience of more enlightened ages. Prepossessions in regard to the duration of past time. As a belief in the want of conformity in the causes by which the earth's crust has been modified in ancient and modern periods was, for a long time, universally prevalent, and that, too, amongst men who were convinced that the order of nature had been uniform for the last several thousand years, every circumstance which could have influenced their minds and given an undue bias to their opinions deserves particular attention. Now, the reader may easily satisfy himself that, however undeviating the course of nature may have been from the earliest epochs, it was impossible for the first cultivators of geology to come to such a conclusion, so long as they were under a delusion as to the age of the world and the date of the first creation of animate beings. However fantastical some theories of the 16th century may now appear to us, however unworthy of men of great talent and sound judgment, we may rest assured that, if the same misconception now prevailed in regard to the memorials of human transactions, it would give rise to a similar train of absurdities. Let us imagine, for example, that Champollion and the French and Tuscan literati lately engaged in exploring the antiquities of Egypt had visited that country with a firm belief that the banks of the Nile were never peopled by the human race before the beginning of the 19th century, and that their faith in this dogma was as difficult to shake as the opinion of our ancestors that the earth was never the abode of living beings until the creation of the present continents and of the species now existing. It is easy to perceive what extravagant systems they would frame while under the influence of this delusion to account for the monuments discovered in Egypt. The sight of the pyramids, obelisks, colossal statues, and ruined temples would fill them with such astonishment that for a time they would be as men spellbound, wholly incapable of reasoning with sobriety. They might incline at first to refer the construction of such stupendous works to some superhuman powers of primeval world. A system might be invented resembling that so gravely advanced by Manetho, who relates that a dynasty of gods originally ruled in Egypt, of whom Vulcan, the first monarch, reigned 9,000 years, after whom came Hercules and other demigods who were at last succeeded by human kings. When some fanciful speculations of this kind had amused their imaginations for a time, some vast repository of mummies would be discovered, and would immediately undeceive those antiquaries who enjoyed an opportunity of personally examining them. But the prejudices of others at a distance who were not eyewitnesses of the whole phenomena would not be so easily overcome. The concurrent report of many travelers would, indeed, render it necessary for them to accommodate ancient theories to some of the new facts, and much wit and ingenuity would be required to modify and defend their old positions. Each new invention would violate a greater number of known analogies, for if a theory be required to embrace some false principle, it becomes more visionary in proportion as facts are multiplied, as would be the case if geometers were now required to form an astronomical system on the assumption of the immobility of the earth. Amongst other fanciful conjectures concerning the history of Egypt, we may suppose some of the following to be started. Quote, "As the banks of the Nile have been so recently colonized for the first time, the curious substances called mummies could never in reality have belonged to men. They may have been generated by some plastic virtue residing in the interior of the earth, or they may be abortions of nature produced by her incipient efforts in the work of creation. For if deformed beings are sometimes born even now, when the scheme of the universe is fully developed, many more may have been sent before their time, scarce half made up, when the planet itself was in the embryo state. But if these notions appear to derogate from the perfection of the divine attributes, and if these mummies be in all their parts true representations of the human form, may we not refer to them to their future rather than the past? May we not be looking into the womb of nature and not her grave? May not these images be like the shades of the unborn in Virgil's Elysium, the archetypes of men not yet called into existence?" End quote. These speculations, if advocated by eloquent writers, would not fail to attract many zealous votaries, for they would relieve men from the painful necessity of renouncing preconceived opinions. Incredible as such skepticism may appear, it has been rivaled by many systems of the 16th and 17th centuries, and among others by that of the learned Falloppio, who regarded the tusks of fossil elephants as earthy concretions, and the pottery fragments of vases in the Monte Testaccio near Rome as works of nature and not of art. But when one generation had passed away and another, not compromised to the support of antiquated dogmas, had succeeded, they would review the evidence afforded by mummies more impartially, and would no longer controvert the preliminary question that human beings had lived in Egypt before the 19th century, so that when 100 years perhaps had been lost, the industry and talents of the philosopher would be at last directed to the elucidation of points of real historical importance. But the above arguments are aimed against only one of the many prejudices with which the earlier geologists had to contend. Even when they conceded that the earth had been peopled with animate beings at an earlier period than was at first supposed, they had no conception that the quantity of time bore so great a proportion to the historical era as is now generally conceded. How fatal every error as to the quantity of time must prove to the introduction of rational views concerning the state of things in former ages, may be conceived by supposing the annals of the civil and military transactions of a great nation to be perused under the impression that they occurred in a period of 100 instead of 2,000 years. Such a portion of history would immediately assume the air of a romance. The events would seem devoid of credibility and inconsistent with the present course of human affairs. A crowd of incidents would follow each other in thick succession. Armies and fleets would appear to be assembled only to be destroyed, and cities built merely to fall into ruins. There would be the most violent transitions from foreign or intestine wars to periods of profound peace, and the works effected during the years of disorder or tranquility would appear alike superhuman in magnitude. He who should study the monuments of the natural world under the influence of a similar infatuation must draw a no less exaggerated picture of the energy and violence of causes, and must experience the same insurmountable difficulty in reconciling the former and present state of nature. If we could behold in one view all the volcanic cones thrown up in Iceland, Italy, Sicily, and other parts of Europe during the last 5,000 years, and could see the lavas which have flowed during the same period, the dislocations, subsidences, and elevations caused during earthquakes, the lands added to various deltas or devoured by the sea, together with the effects of devastation by floods, and imagine that all these events had happened in 1 year, we must form most exalted ideas of the activity of the agents and the suddenness of the revolutions. Were an equal amount of change to pass before our eyes in the next year, could we avoid the conclusion that some great crisis of nature was at hand? If geologists, therefore, have misinterpreted the signs of a succession of events so as to conclude that centuries were implied where the characters imported thousands of years, and thousands of years where the language of nature signified millions, they could not, if they reasoned logically from such false premises, come to any other conclusion than that the system of the natural world had undergone a complete revolution. We should be warranted in ascribing the erection of the Great Pyramid to superhuman power if we were convinced that it was raised in one day, and if we imagine in the same manner a continent or mountain chain to have been elevated during an equally small fraction of the time which was really occupied in upheaving it. We might then be justified in inferring that the subterranean movements were once far more energetic than in our own times. We know that during one earthquake, the coast of Chile may be raised for 100 miles to the average height of about 3 feet. A repetition of 2,000 shocks of equal violence might produce a mountain chain 100 miles long and 6,000 feet high. Now, should one or two only of these convulsions happen in a century, it would be consistent with the order of events experienced by the Chileans from the earliest times. But if the whole of them were to occur in the next 100 years, the entire district must be depopulated, scarcely any animals or plants could survive, and the surface would be one confused heap of ruin and desolation. One consequence of undervaluing greatly the quantity of past time is the apparent coincidence which it occasions of events necessarily disconnected, or which are so unusual that it would be inconsistent with all calculation of chances to suppose them to happen at one and the same time. When the unlooked-for association of such rare phenomena is witnessed in the present course of nature, it scarcely fails to excite a suspicion of the preternatural in those minds which are not firmly convinced of the uniform agency of secondary causes, as if the death of some individual in whose fate they are interested happens to be accompanied by the appearance of a luminous meteor or a comet or the shock of an earthquake. It would be only necessary to multiply such coincidences indefinitely, and the mind of every philosopher would be disturbed. Now, it would be difficult to exaggerate the number of physical events, many of them most rare and unconnected in their nature, which were imagined by the Woodwardian hypothesis to have happened in the course of a few months. And numerous other examples might be found of popular geologic theories, which require us to imagine that a long succession of events happen in a brief and almost momentary period. Another liability to error, very nearly allied to the former, arises from the frequent contact of geological monuments referring to very distant periods of time. We often behold at one glance the effects of causes which have acted at times incalculably remote. And yet there may be no striking circumstances to mark the occurrence of a great chasm in the chronological series of nature's archives. In the vast interval of time which may really have elapsed between the results of operations thus compared, the physical condition of the earth may, by slow and insensible modifications, have become entirely altered. One or more races of organic beings may have passed away, and yet have left behind, in the particular region under contemplation, no trace of their existence. To a mind unconscious of these intermediate events, the passage from one state of things to another must appear so violent that the idea of revolutions in the system inevitably suggests itself. The imagination is as much perplexed by the deception as it might be if two distant points in space were suddenly brought into immediate proximity. Let us suppose, for a moment, that a philosopher should lie down to sleep in some Arctic wilderness and then be transferred by a power, such as we read of in Tales of Enchantment, to a valley in a tropical country where, on awakening, he might find himself surrounded by birds of brilliant plumage and all the luxuriance of animal and vegetable forms of which nature is so prodigal in those regions. The most reasonable supposition, perhaps, which he could make, if by the necromancer's art he were placed in such a situation, would be that he was dreaming. And if a geologist form theories under a similar delusion, we cannot expect him to preserve more consistency in his speculations than in the train of ideas in an ordinary dream. It may afford, perhaps, a lively illustration of the principle here insisted upon if I recall to the reader's recollection the legend of the Seven Sleepers. The scene of that popular fable was placed in the 2 centuries which elapsed between the reign of the Emperor Decius and the death of Theodosius the Younger. In that interval of time, between the years 249 and 450 of our era, the union of the Roman Emperor had been dissolved, and some of its fairest provinces overrun by the barbarians of the north. The seat of government had passed from Rome to Constantinople, and the throne from a pagan prosecutor to a succession of Christian and Orthodox princes. The genius of the empire had been humbled in the dust, and the altars of Diana and Hercules were on the point of being transferred to Catholic saints and martyrs. The legend relates, quote, that when Decius was still persecuting the Christians, 7 noble youths of Ephesus concealed themselves in a spacious cavern on the side of an adjacent mountain, where they were doomed to perish by the tyrant, who gave orders that the entrance should be firmly secured with a pile of huge stones. They immediately fell into a deep slumber, which was miraculously prolonged, without injuring the powers of life during a period of 187 years. At the end of that time, the slaves of Adulius, to whom the inheritance of the mountain had descended, removed the stones to supply materials for some rustic edifice. The light of the sun darted into the cavern, and the 7 sleepers were permitted to wake. After a slumber, as they thought, of a few hours, they were pressed by the calls of hunger, and resolved that Jamblichus, one of their number, should secretly return to the city to purchase bread for use of his companions. The youth could no longer recognize the once familiar aspect of his native country, and his surprise was increased by the appearance of a large cross triumphantly erected over the principal gate of Ephesus. His singular dress and obsolete language confounded the baker, to whom he offered an ancient medal of Decius as the current coin of the empire. And Jamblichus, on the suspicion of a secret treasure, was dragged before the judge. Their mutual inquiries produced the amazing discovery that 2 centuries were almost elapsed since Jamblichus and his friends had escaped from the rage of a pagan tyrant. End quote. This legend was received as authentic throughout the Christian world before the end of the 6th century, and was afterwards introduced by Mahomet as a divine revelation into the Quran, and from hence was adopted and adorned by all the nations from Bengal to Africa who profess the Mahometan faith. Some vestiges even of a similar tradition have been discovered in Scandinavia. Quote, this easy and universal belief, end quote, observes the philosophical historian of the Decline and Fall, quote, so expressive of the sense of mankind, may be described to the genuine merit of the fable itself. We imperceptibly advance from youth to age without observing the gradual but incessant change of human affairs. And even in our larger experience of history, the imagination is accustomed by a perpetual series of causes and effects to unite the most distant revolutions. But if the interval between 2 memorable eras could be instantly annihilated, if it were possible after a momentary slumber of 200 years to display a new world to the eyes of a spectator who still retained a lively and recent impression of the old, his surprise and his reflections would furnish the pleasing subject of a philosophical romance. End quote. Prejudices arising from our peculiar position as inhabitants of the land. The sources of prejudice hitherto considered may be deemed peculiar for the most part to the infancy of the science, but others are common to the first cultivators of geology and to ourselves, and are all singularly calculated to produce the same deception, and to strengthen our belief that the course of nature in the earlier ages differed widely from that now established. Although these circumstances cannot be fully explained without assuming some things as proved, which it will be the subject of another part of this work to demonstrate, it may be well to allude to them briefly in this place. The first and greatest difficulty, then, consists of an habitual unconsciousness that our position as observers is essentially unfavorable when we endeavor to estimate the nature and magnitude of the changes now in progress. In consequence of our inattention to this subject, we are liable to serious mistakes in contrasting present with former states of the globe. As dwellers on the land, we inhabit about a 4th part of the surface, and that portion is almost exclusively a theater of decay and not of reproduction. We know, indeed, that new deposits are annually formed in seas and lakes, and that every year some new igneous rocks are produced in the bowels of the earth, but we cannot watch the progress of their formation, and as they are only present to our mind by the aid of reflection, it requires an effort both of the reason and the imagination to appreciate duly their importance. It is, therefore, not surprising that we estimate very imperfectly the result of operations thus invisible to us, and that when analogous results of former epochs are presented to our inspection, we cannot immediately recognize the analogy. He who has observed the quarrying of stone from a rock, and has seen it shipped for some distant port, and then endeavors to conceive what kind of edifice will be raised by the materials, is in the same predicament as a geologist, who, while he is confined to the land, sees the decomposition of rocks and the transportation of matter by rivers to the sea, and then endeavors to picture to himself the new strata which nature is building beneath the waters. Prejudices arising from our not seeing subterranean changes. Nor is his position less favorable when, beholding a volcanic eruption, he tries to conceive what changes the column of lava has produced in its passage upwards on the intersected strata. or what form the melted matter may assume at great depths on cooling, or what may be the extent of subterranean rivers and reservoirs of liquid matter far beneath the surface. It should therefore be remembered that the task imposed on those who study the Earth's history requires no ordinary share of discretion, for we are precluded from collating the corresponding parts of the system of things as it exists now, and as it existed at former periods. If we were inhabitants of another element, if the great ocean were our domain instead of the narrow limits of the land, our difficulties would be considerably lessened, while on the other hand there can be little doubt, although the reader may perhaps smile at the bare suggestion of such an idea, that an amphibious being who should possess our faculties would still more easily arrive at sound theoretical opinions in geology, since he might behold, on the one hand, the decomposition of rocks in the atmosphere, or the transportation of matter by running water, and on the other, examine the deposition of sediment in the sea, and the embedding of animal and vegetable remains in new strata. He might ascertain by direct observation the action of a mountain torrent, as well as of a marine current, might compare the products of volcanoes poured out upon the land with those ejected beneath the waters, and might mark, on the one hand, the growth of the forest, and on the other, that of the coral reef. Yet, even with these advantages, he would be liable to fall into the greatest errors when endeavoring to reason on rocks of subterranean origin. He would seek in vain, within the spheres of his observation, for any direct analogy to the process of their formation, and would therefore be in danger of attributing them, wherever they are upraised to view, to some, quote, primeval state of nature, end quote. But if we may be allowed so far to indulge the imagination as to suppose a being entirely confined to the netherworld, some, quote, dusky melancholy sprite, end quote, like Umbriel, who could, quote, flit on sooty pinions to the central earth, end quote, but who was never permitted to, quote, sully the fair face of light, end quote, and submerge into the regions of air and water. And if this being should busy himself in investigating the structure of the globe, he might frame theories the exact converse of those usually adopted by human philosophers. He might infer that the stratified rocks containing shells and other organic remains were the oldest of created things, belonging to some original and nascent state of the planet. He might say, quote, of these masses, whether they consist of loose, incoherent sand, soft clay, or solid stone, none have been formed in modern times. Every year some part of them are broken and shattered by earthquakes, or melted by volcanic fire. And when they cool down slowly from a state of fusion, they assume a new and more crystalline form, no longer exhibiting that stratified deposition and those curious impressions and fantastic markings by which they were previously characterized. This process cannot have been carried on for an indefinite time, for in that case all the stratified rocks would long ere this have been fused and crystallized. It is therefore probable that the whole planet once consisted of these mysterious and curiously bedded formations at a time when the volcanic fire had not yet been brought into activity. Since that period there seems to have been a gradual development of heat, and this augmentation may expect to continue until the whole globe shall be in a state of fluidity and incandescence, end quote. Such might be the system of the gnome at the very time that the followers of Leibniz, reasoning on what they saw on the outer surface, might be teaching the opposite doctrine of gradual refrigeration, and averring that the Earth had begun its career as a fiery comet and might be destined hereafter to become a frozen mass. The tenets of the schools of the nether and of the upper world would be directly opposed to each other, for both would partake of the prejudices inevitably resulting from the continual contemplation of one class of phenomena to the exclusion of another. Man observes the annual decomposition of crystalline and igneous rocks, and may sometimes see their conversion into stratified deposits, but he cannot witness the reconversion of the sedimentary into the crystalline by subterranean fire. He is in the habit of regarding all the sedimentary rocks as more recent than the unstratified, for the same reason that we may suppose him to fall into the opposite error if he saw the origin of the igneous class only. It was not an impossible contingency that astronomers might have been placed at some period in a situation much resembling that in which the geologist seems to stand at present. If the Italians, for example, in the early part of the 12th century, had discovered at Amalfi, instead of the Pandects of Justinian, some ancient manuscripts filled with astronomical observations relating to a period of 3,000 years, and made by some ancient geometers who possessed optical instruments as perfect as any in modern Europe, they would probably, on consulting these memorials, have come to a conclusion that there had been a great revolution in the solar and sidereal systems. They might say, quote, many primary and secondary planets are enumerated in these tables, which exist no longer. Their positions are assigned with such precision that we may assure ourselves that there is nothing in their place at present but the blue ether. Where one star is visible to us, these documents represent several thousands. Some of those which are now single consisted then of two separate bodies, often distinguished by different colors and revolving periodically around a common center of gravity. There is nothing analogous to them in the universe at present, for they were neither fixed stars nor planets, but seem to have stood in the mutual relation of sun and planet to each other. We must conclude, therefore, that there has occurred at no distant period a tremendous catastrophe whereby thousands of worlds have been annihilated at once, and some heavenly bodies absorbed into the substance of others. When such doctrines had prevailed for ages, the discovery of some of the worlds supposed to have been lost, the satellites of Jupiter, for example, by aid of the first rude telescope invented after the revival of science, would not dissipate the delusion. For the whole burden of proof would now be thrown on those who insisted on the stability of the system from a remote period, and those philosophers would be required to demonstrate the existence of all the worlds said to have been annihilated. Such popular prejudices would be most unfavorable to the advancement of astronomy. For, instead of persevering in the attempt to improve their instruments and laboriously to make and record observations, the greater number would despair of verifying the continued existence of the heavenly bodies not visible to the naked eye. Instead of confessing the extent of their ignorance and striving to remove it by bringing to light new facts, they would indulge in the more easy and indolent employment of framing imaginary theories concerning catastrophes and mighty revolutions in the system of the universe. For more than 2 centuries, the shelly strata of the sub-Apennine hills afforded matter of speculation to the early geologists of Italy, and few of them had any suspicion that similar deposits were then forming in the neighboring sea. They were as unconscious of the continued action of causes still producing similar effects as the astronomers, in the case above supposed, of the existence of certainly heavenly bodies still giving and reflecting light and performing their movements as of old. Some imagine that the strata so rich in organic remains, instead of being due to secondary agents, had been so created in the beginnings of things by the fiat of the Almighty. Others, as we have seen, ascribe the embedded fossil bodies to some plastic power which resided in the earth in the early ages of the world. In what manner were these dogmas at length exploded? The fossil relics were carefully compared with their living analogues, and all doubt as to their organic origin were eventually dispelled. So also in regard to the nature of the containing beds of mud, sand, and limestone. Those parts of the bottom of the sea were examined where shells are now becoming annually entombed in new deposits. Donati explored the beds of the Adriatic, and found the closest resemblance between the strata there forming and those which constituted hills above 1,000 feet high in various parts of the Italian peninsula. He ascertained by dredging that living testacea were there grouped together in precisely the same manner as were their fossil analogues in the inland strata. And while some of the recent shells of the Adriatic were becoming encrusted with calcareous rock, he observed that others had been newly buried in sand and clay, precisely as fossil shells occur in the sub-Apennine hills. This discovery of the identity of modern and ancient submarine operations was not made without the aid of artificial instruments, which, like the telescope, brought phenomena into view not otherwise within the sphere of human observation. In like manner, the volcanic rocks of the Vicentin had been studied in the beginning of the last century, but no geologist suspected before the time of Arduino that these were composed of ancient submarine lavas. During many years of controversy, the popular opinion inclined to a belief that basalt and rocks of the same class had been precipitated from a chaotic fluid, or an ocean which arose at successive periods over the continents, charged with the component elements of the rocks in question. Few will now dispute that it would have been difficult to invent a theory more distant from the truth, yet we must cease to wonder that it gained so many proselytes, when we remember that its claims to probability arose partly from the very circumstance of its confirming the assumed want of analogy between geological causes and those now in action. By what train of investigations were geologists induced at length to reject those views, and to assent to the igneous origin of the Trappean formations? By an examination of volcanoes now active, and by comparing their structure and the composition of their lavas with the ancient trap rocks. The establishment from time to time of numerous points of identification drew at length from geologists a reluctant admission that there was more correspondence between the condition of the globe at remote eras and now, and more uniformity in the laws which have regulated the changes of its surface, than they at first imagined. If, in this state of the science, they still despaired of reconciling every class of geological phenomena to the operations of ordinary causes, even by straining analogy to the utmost limits of credibility, we might have expected at least that the balance of probability would now have been presumed to incline towards the close analogy of the ancient and modern causes. But after repeated experience of the failure of attempts to speculate on geological monuments as belonging to a distant order of things, new sects continued to persevere in the principles adopted by their predecessors. They still began, as each new problem presented itself, whether relating to the animate or inanimate world, to assume an original and dissimilar order of nature, and when at length they approximated or entirely came round to an opposing opinion, it was always with a feeling that they were conceding that they had been justified a priori in deeming improbable. In a word, the same men who, as natural philosophers, would have been most incredulous respecting any extraordinary deviations from the known course of nature, if reported to have happened in their own time, were equally disposed as geologists to expect the proofs of such deviations to every period of the past. I shall proceed in the following chapters to enumerate some of the principal difficulties still opposed to the theory of the uniform nature and energy of the causes which have worked successive changes in the crust of the earth and in the condition of its living inhabitants. The discussion of so important a question in the present occasion may appear premature, but it is one which naturally arises out of a review of the former history of the science. It is, of course, impossible to enter into such speculative topics without occasionally carrying the novice beyond his depth, and appealing to facts and conclusions with which he will be unacquainted, until he has studied some elementary work on geology, but it may be useful to excite his curiosity and lead him to study such works by calling his attention at once to some of the principal points of controversy. Chapter 6. Doctrine of the Discordance of the Ancient and Modern Causes of Change Controverted. Climate of the Northern Hemisphere formerly different. Proofs of former revolutions in climate, as deduced from fossil remains, have afforded one of the most popular objections to the theory which endeavors to explain all geological changes by reference to those now in progress on the Earth. The probable causes, therefore, of fluctuations in climate may first be treated of. That the climate of the Northern Hemisphere has undergone an important change, and that its mean annual temperature must once have more nearly resembled that now experienced within the tropics, was the opinion of some of the first naturalists who investigated the contents of the ancient strata. Their conjecture became more probable when the shells and corals of the older tertiary and many secondary rocks were carefully examined, for the organic remains of these formations were found to be intimately connected by generic affinity with species now living in warmer latitudes. At a later period, many reptiles, such as turtles, tortoises, and large saurian animals, were discovered in European formations in great abundance, and they supplied new and powerful arguments from analogy in support of the doctrine that the heat of the climate had been great when our secondary strata were deposited. Lastly, when the botanist turned his attention to the specific determination of fossil plants, the evidence acquired still fuller confirmation. For the flora of a country is peculiarly influenced by temperature, and the ancient vegetation of the earth might have been expected more readily than the forms of the animals to have afforded conflicting proofs had the popular theory been without foundation. When the examination of fossil remains was extended to rocks in most northern parts of Europe and North America, and even to the Arctic regions, indications of the same revolution in climate were discovered. It cannot be said that in this, as in many other departments of geology, we have investigated the phenomena of former eras and neglected those of the present state of things. On the contrary, since the first agitation of this interesting question, the accessions to our knowledge of living animals and plants have been immense, and have far surpassed all the data previously obtained for generalizing on the relation of certain types of organization to particular climates. The tropical and temperate zones of South America and of Australia have been explored, and on close comparison it has been found that scarcely any of the species of the animate creation in these extensive continents are identical with those inhabiting the Old World. Yet the zoologist and botanist, well acquainted with the geographical distribution of organic beings in other parts of the globe, would have been able, if distinct groups of species had been presented to them from these regions, to recognize those which had been collected from latitudes within and those which were brought from without the tropics. Before I attempt to explain the probable cause of great vicissitudes of temperature on the Earth's surface, I shall take a rapid view of some of the principal data which appear to support the popular opinions now entertained on the subject. To insist on the soundness of these inferences is the more necessary because some zoologists have undertaken to vindicate the uniformity of the laws of nature not by accounting for former fluctuations in climate, but by denying the value of evidence in their favor. Proofs from fossil shells in tertiary strata. In Sicily, Calabria, and in the neighborhood of Naples, the fossil testacea of the most modern tertiary formations belong almost entirely to new species now inhabiting the Mediterranean. But as we proceed northwards in the Italian peninsula, we find in the strata called subapennine an assemblage of fossil shells departing somewhat more widely from the type of the neighboring seas. The proportion of species identifiable with those now living in the Mediterranean is still considerable, but it no longer predominates, as in the south of Italy and part of Sicily, over the unknown species. Although occurring in localities which are removed several degrees farther from the equator, as at Siena, Parma, Asti, etc., the shells yield clear indications of a warmer climate. This evidence is of great weight and is not neutralized by any facts of a conflicting character, such, for instance, as the association in the same group of individuals referable to species now confined to Arctic regions. Whenever any of the fossil shells are identified with living species foreign to the Mediterranean, it is not in the northern ocean, but nearer the tropics, that they must be sought. On the other hand, the associated unknown species belong, for the most part, to genera which are now most largely developed in equinoctial regions, as, for example, the genera Cancelaria, Cassidaria, Plurotoma, Conus, and Cypriae. On comparing the fossils of the tertiary deposits of Paris and London with those of Bordeaux, and these again with the more modern strata of Sicily, we should at first expect that they would each indicate a higher temperature in proportion as they are situated farther to the south. But the contrary is true. Of the shells belonging to these several groups, whether freshwater or marine, some are extinct, others of living species. Those found in the older or Eocene deposits of Paris and London, although 6 or 7 degrees to the north of the Miocene strata at Bordeaux, afford evidence of a warmer climate, while those of Bordeaux imply that the sea in which they lived was of a higher temperature than that of Sicily, where the shelly strata were formed 6 or 7 degrees nearer to the equator. In these cases, the greater antiquity of the several formations, the Parisian being the oldest and the Sicilian the newest, has more than counterbalanced the influence which latitude would otherwise exert, and this phenomenon clearly points to a gradual and successive refrigeration of climate. Siberian mammoths. It will naturally be asked whether some recent geological discoveries bringing evidence to light of a colder, or as it has been termed, quote, glacial epoch, end quote, towards the close of the tertiary periods throughout the northern hemisphere, does not conflict with the theory above alluded to of a warmer temperature having prevailed in the areas of the Eocene, Miocene, and Pliocene formations. In answer to this inquiry, it may certainly be affirmed that an oscillation of climate has occurred in times immediately antecedent to the peopling of the earth by man. But proof of the intercalation of a less genial climate at an era when nearly all the marine and terrestrial testacea had already become specifically the same as those now living, by no means rebuts the conclusion previously drawn, in favor of a warmer condition of the globe during the ages which elapsed while the tertiary strata were deposited. In some of the most superficial patches of sand, gravel, and loam scattered very generally over Europe and containing recent shells, the remains of extinct species of land quadrupeds have been found, especially in places where the alluvial matter appears to have been washed into small lakes or into depressions in the plains bordering ancient rivers. Similar deposits have also been lodged in rents and caverns of rocks, where they may have been swept in by land floods or introduced by engulfed rivers during changes in the physical geography of these countries. The various circumstances under which the bones of animals have been thus preserved will be more fully considered hereafter. I shall only state here that among the extinct mammalia thus entombed, we find species of the elephant, rhinoceros, hippopotamus, bear, hyena, lion, tiger, monkey, macacus, and many others, consisting partly of genera now confined to warmer regions. It is certainly probable that when some of these quadrupeds abounded in Europe, the climate was milder than that now experienced. The hippopotamus, for example, is now only met with where the temperature of the water is warm and nearly uniform throughout the year, and where the rivers are never frozen over. Yet when the great fossil species, Hippopotamus major, inhabited England, the testacea of our country were nearly the same as those now existing, and the climate cannot be supposed to have been very hot. The bones of this animal have lately been found by Mr. Strickland, together with those of a bear and other mammalia, at Cropthorne, near Evesham, in Worcester, in alluvial sand, together with 23 species of terrestrial and freshwater shells, all with 2 exceptions of British species. The bed of sand containing the shells and bones reposes on lias, and is covered with alternating strata of gravel, sand, and loam. The mammoth also appears to have existed in England when the temperature of our latitudes could not have been very different from that which now prevails, for remains of this animal have been found at Northcliffe, in the country of York, in a lacustrine formation in which all the land and freshwater shells, 13 in number, can be identified with species and varieties now existing in that county. Bones of the bison, also, an animal now inhabiting a cold or temperate climate, have been found in the same place. That these quadrupeds and the indigenous species of testacea not associated with them were all contemporary inhabitants of Yorkshire has been established by unequivocal proof. The Reverend W. V. Vernon Harcourt caused a pit to be sunk to the depth of 22 feet through undisturbed strata, in which the remains of the mammoth were found embedded, together with the shells, in a deposit which had evidently resulted from tranquil waters. In the valley of the Thames, as at Ilford and Grays, in Essex, bones of the elephant and rhinoceros occur in strata abounding in freshwater shells of the genera Unio, Cyclus, Paludina, Valvata, Ancillus, and others. These fossil shells belong for the most part to species now living in the same district, yet some few of them are extinct, as, for example, the species of Sirena, a genus no longer inhabiting Europe and now entirely restricted to warmer latitudes. When reasoning on such phenomena, the reader must always bear in mind that the fossil individuals belong to species of elephant, rhinoceros, hippopotamus, bear, tiger, and hyena, distinct from those which now dwell within or near the tropics. Dr. Fleming, in a discussion on this subject, has well remarked that a near resemblance in form and osteological structure is not always followed, in the existing creation, by a similarity of geographical distribution, and we must therefore be on our guard against deciding too confidently, from mere analogy of anatomical structure, respecting the habits and physiological peculiarities of species now no more. Quote, "The zebra delights to roam over the tropical plains, while the horse can maintain its existence throughout an Iceland winter. The buffalo, like the zebra, prefers a high temperature and cannot thrive even where the common ox prospers. The muskox, on the other hand, though nearly resembling the buffalo, prefers the stinted herbage of the Arctic regions, and is able, by its periodical migrations, to outlive a northern winter. The jackal, Canis aureus, inhabits Africa, the warmer parts of Asia and Greece, while the asatis, Canis lagopus, resides in the Arctic regions. The African hare and the polar hare have their geographical distributions expressed in their trivial names," end quote. And different species of bears thrive in tropical, temperate, and Arctic latitudes. Recent investigations have placed beyond all doubt the important fact that a species of tiger, identical with that of Bengal, is common in the neighborhood of Lake Aral, near Sussex, in the 45th degree of north latitude, and from time to time this animal is now seen in Siberia, in a latitude as far north as the parallel of Berlin and Hamburg. Humboldt remarks that the parts of southern Asia now inhabited by this Indian species of tiger is separated from the Himalaya by 2 great chains of mountains, each covered with perpetual snow. The chain of Kuan-Lan, latitude 35 degrees north, and that of Mauztak, latitude 42 degrees, so that it is impossible that these animals should merely have made excursions from India, so as to have penetrated in summer to the 48th and 53rd degrees of north latitude. They must remain all the winter north of the Mauztak, or Celestial Mountains. The last tiger killed in 1828 on the Lena, in latitude 52¼ degrees, was in a climate colder than that of Petersburg and Stockholm. We learn from Mr. Hodgson's account of the mammalia of Nepal that the tiger is sometimes found at the very edge of perpetual snow in the Himalaya, and Pennant mentions that it is found among the snows of Mount Ararat in Armenia. The jaguar also has been seen in America, wandering from Mexico as far north as Kentucky, latitude 37 degrees north, and even as far as 42 degrees south in South America, a latitude which corresponds to that of the Pyrenees in the northern hemisphere. The range of the puma is still wider, for it roams from the equator to the Straits of Magellan, being often seen at Port Famine in latitude 53 degrees 38 seconds south. A new species of panther, Felis irbis, covered with long hair, has been discovered in Siberia, evidently inhabiting, like the tiger, a region north of the Celestial Mountains, which are in latitude 42 degrees. The two-horned African rhinoceros occurs without the tropics at the Cape of Good Hope in latitude 34 degrees 29 degrees south, where it is accompanied by the elephant, hippopotamus, and hyena. Here, the migration of all these species towards the south is arrested by the ocean, but if the continent had been prolonged still further and the land had been of moderate elevation, it is very probable that they might have extended their range to a greater distance from the tropics. Now, if the Indian tiger can range in our own times to the southern borders of Siberia or skirt the snows of the Himalaya, and if the puma can reach the 53rd degree of latitude in South America, we may easily understand how large species of the same genera may once have inhabited our temperate climates. The mammoth, E. primigenius, already alluded to, as occurring fossil in England, was decidedly different from the two existing species of elephants, one of which is limited to Asia, south of the 31 degree of north latitude, the other to Africa, where it extends, as before stated, as far south as the Cape of Good Hope. The bones of the great fossil species are very widely spread over Europe and North America, but are nowhere in such profusion as in Siberia, particularly near the shores of the frozen ocean. Are we, then, to conclude that this animal preferred a polar climate? If so, it may well be asked by what food was it sustained, and why does it not still survive near the Arctic Circle? Pallas and other writers described the bones of the mammoth as abounding throughout all the lowlands of Siberia, stretching in a direction west and east from the borders of Europe to the extreme point nearest America, and south and north from the base of the mountains of Central Asia to the shores of the Arctic Sea. Within this space, scarcely inferior in area to the whole of Europe, fossil ivory has been collected almost everywhere, on the banks of the Irtish, Obi Yenisei, Lena, and other rivers. The elephantine remains do not occur in the marshes and low plains, but where the banks of rivers present lofty precipices of sand and clay, from which circumstance Pallas very justly inferred that, if sections could be obtained, similar bones might be found in all the elevated lands intervening between the great rivers. Strahlenberg, indeed, had stated before the time of Pallas that wherever any of the great rivers overflowed and cut out fresh channels during floods, more fossil remains of the same kind were invariably disclosed. As to the position of the bones, Pallas found them in some places embedded together with marine remains, in others simply with fossil wood or lignite, such as, he says, might have been derived from carbonized peat. On the banks of the Yenisei, below the city of Krasnoyarsk, in latitude 56 degrees, he observed grinders and bones of elephants in strata of yellow and red loam, alternating with coarse sand and gravel, in which was also much petrified wood of willow and other trees. Neither here nor in the neighboring country were there any marine shells, but merely layers of black coal. But grinders of the mammoth were collected much further down the same river, near the sea in latitude 70 degrees, mixed with marine petrifications. Many other places in Siberia are cited by Pallas where seashells and fishes' teeth accompany the bones of the mammoth, rhinoceros, and Siberian buffalo, or bison, Bos priscus. But it is not on the Obi or the Yenisei, but on the Lena further to the east, where, in the same parallels of latitude, the cold is far more intense, that fossil remains have been found in the most wonderful state of preservation. In 1772, Pallas obtained from Wilewiski, in latitude 64 degrees from the banks of the Wilui, a tributary of the Lena, the carcass of the rhinoceros R. ticorinus, taken from the sand in which it must have remained congealed for ages, the soil of that region being always frozen to within a slight depth of the surface. This carcass was compared to a natural mummy, and emitted an odor like putrid flesh, part of the skin being still covered with black and gray hairs. So great, indeed, was the quantity of hair on the foot and head conveyed to St. Petersburg, that Pallas asked whether the rhinoceros of the Lena might not have been an inhabitant of the temperate regions of Middle Asia, its clothing being so much warmer than that of the African rhinoceros. Professor Brandt of St. Petersburg, in a letter to Baron Alex von Humboldt, dated 1846, adds the following particulars respecting this wonderful fossil relic. Quote, I have been so fortunate as to extract from cavities in the molar teeth of the Wilui rhinoceros a small quantity of its half-chewed food, among which fragments of pine leaves, 1/2 of the seed of a polygonaceous plant, and very minute portions of wood with porous cells, or small fragments of coniferous wood, were still recognizable. It was also remarkable, on a close investigation of the head, that the blood vessels discovered in the interior of the mass appeared filled, even to the capillary vessels, with a brown mass coagulated blood, which in many places still showed the red color of blood." End quote. After more than 30 years, the entire carcass of a mammoth, or extinct species of elephant, was obtained in 1803 by Mr. Adams, much farther to the north. It fell from a mass of ice in which it had been encased on the banks of the Lena, in latitude 70 degrees. And so perfectly had the soft parts of the carcass been preserved that the flesh as it lay was devoured by wolves and bears. This skeleton is still in the Museum of St. Petersburg, the head retaining its integument and many of the ligaments entire. The skin of the animal was covered first with black bristles thicker than horsehair from 12 to 16 inches in length, secondly with hair of a reddish-brown color about 4 inches long, and thirdly with wool of the same color as the hair about an inch in length. Of the fur, upwards of 30 pounds weight were gathered from the wet sandbank. The individual was 9 feet high and 16 feet long, without reckoning the large curved tusks, a size rarely surpassed by the largest living male elephants. It is evident, then, that the mammoth, instead of being naked like the living Indian or African elephants, was enveloped in thick, shaggy covering of fur, probably as impenetrable to rain and cold as that of the musk ox. The species may have been fitted by nature to withstand the vicissitudes of a northern climate, and it is certain that, from the moment when the carcass both of the rhinoceros and elephant above described were buried in Siberia, in latitudes 64 degrees and 70 degrees north, the soil must have remained frozen, and the atmosphere nearly as cold as at this day. The most recent discoveries made in 1843 by Mr. Middendorf, a distinguished Russian naturalist, and which he communicated to me in September 1846, afford more precise information as to the climate of the Siberian lowlands at the period when the extinct quadrupeds were entombed. One elephant was found on the Tass, between the Obi and Yenisei, near the Arctic Circle, about latitude 66 degrees 30 minutes north, with some parts of the flesh in so perfect a state that the bulb of the eye is now preserved in the museum at Moscow. Another carcass, together with a young individual of the same species, was met in the same year, 1843, in latitude 75 degrees 15 minutes north, near the river Tamer, with the flesh decayed. It was embedded in strata of clay and sand with erratic blocks at about 15 feet above the level of the sea. In the same deposit, Mr. Middendorf observed the trunk of a large tree, Pinus larix, the same wood as that now carried down in abundance by the Taimur to the Arctic Sea. There were also associated fossil shells of living northern species, and which are moreover characteristic of the drift or glacial deposits of Europe. Among these, Nucula pygmae, Talina calcareae, Maya truncata, and Saxicava rugosa were conspicuous. So fresh is the ivory throughout northern Russia that, according to Tilesius, thousands of fossil tusks have been collected and used in turning, yet others are still procured and sold in great plenty. He declares his belief that the bones still left in northern Russia must greatly exceed in number all the elephants now living on the globe. We are as yet ignorant of the entire geographical range of the mammoth, but its remains have been recently collected from the cliffs of frozen mud and ice on the east side of Bering Straits, in Eschscholtz Bay, in Russian America, latitude 66 degrees north. As the cliffs waste away by the thawing of the ice, tusks and bones fall out, and a strong odor of animal matter is exhaled from the mud. On considering all the facts above enumerated, it seems reasonable to imagine that a large region in Central Asia, including, perhaps, the southern half of Siberia, enjoyed at no very remote period in the Earth's history a temperate climate, sufficiently mild to afford food for numerous herds of elephants and rhinoceroses, of species distinct from those now living. It has usually been taken for granted that herbivorous animals of large size require a very luxuriant vegetation for their support. But this opinion is, according to Mr. Darwin, completely erroneous. He says, quote, "It has been derived from our acquaintance with India and the Indian islands, where the mind has been accustomed to associate troops of elephants with noble forests and impenetrable jungles. But the southern parts of Africa, from the Tropic of Capricorn to the Cape of Good Hope, although sterile and desert, are remarkable for the number of great bulk of indigenous quadrupeds. We there meet with an elephant, 5 species of rhinoceros, a hippopotamus, a giraffe, and boscapher, the eland, 2 zebras, the quagga, 2 gnus, and several antelopes. Nor must we suppose that while the species are numerous, the individuals of each kind are few. Dr. Andrew Smith saw in one day's march in latitude 24 degrees south, without wandering to any great distance on either side, about 150 rhinoceroses with several herds of giraffes, and his party had killed on the previous night 8 hippopotamuses. Yet the country which they inhabited was thinly covered with grass and bushes about 4 feet high, and still more thinly with mimosa trees, so that the wagons of the travelers were not prevented from proceeding in a nearly direct line. In order to explain how so many animals can find support in this region, it is suggested that the underwood, of which their food chiefly consists, may contain much nutriment in a small bulk, and also that the vegetation has rapid growth, for no sooner is a part consumed than its place, says Dr. Smith, is supplied by a fresh stock. Nevertheless, after making every allowance for this successive production and consumption, it is clear from the facts above cited that the quantity of food required by the larger herbivora is much less than we have usually imagined. Mr. Darwin conceives that the amount of vegetation supported at any one time by Great Britain may exceed in a tenfold ratio the quantity existing on an equal area in the interior parts of southern Africa. It is remarked, moreover, in illustration of the small connection discoverable between abundance of food and the magnitude of indigenous mammalia, that while in the desert part of southern Africa there are so many huge animals, in Brazil, where the splendor and exuberance of the vegetation are unrivaled, there is not a single wild quadruped of large size. It would doubtless be impossible for herds of mammoths and rhinoceroses to subsist at present throughout the year, even in the southern part of Siberia, covered as it is with snow during winter. But there is no difficulty in supposing a vegetation capable of nourishing these great quadrupeds to have once flourished between the latitudes 40 degrees and 60 degrees north. Dr. Fleming has hinted that, quote, the kind of food which the existing species of elephant prefers will not enable us to determine or even to offer a probable conjecture concerning that of the extinct species. No one acquainted with the gramineous character of the food of our fallow deer, stag, or roe would have assigned a lichen to the reindeer. End quote. Travelers mention that, even now, when the climate of eastern Asia is so much colder than the same parallels of latitude farther west, there are woods not only of fir, but of birch, poplar, and alder on the banks of the Lena as far north as latitude 60 degrees. It has, moreover, been suggested that as, in our own times, the northern animals migrate, so the Siberian elephant and rhinoceros may have wandered towards the north in summer. The musk oxen annually desert their winter quarters in the south and cross the sea upon the ice to graze for 4 months from May to September on the rich pasturage of Melville Island in latitude 75 degrees. The mammoths, without passing so far beyond the Arctic Circle, may nevertheless have made excursions during the heat of a brief northern summer from the central or temperate parts of Asia to the 60th parallel of latitude. Now, in this case, the preservation of their bones, or even occasionally of their entire carcasses, in ice or frozen soil, may be accounted for without resorting to speculations concerning sudden revolutions in the former state and climate of the Earth's surface. We are entitled to assume that, in the time of the extinct elephant and rhinoceros, the lowland of Siberia was less extensive towards the north than now, for we have seen that the strata of this lowland, in which the fossil bones lie buried, were originally deposited beneath the sea, and we know from the facts brought to light in Wrangell's voyage, in the years 1821, 22, and 23, that the slow upheaval of the land along the borders of the icy sea is now constantly taking place, similar to that experienced in part of Sweden. In the same manner, then, as the shores of the Gulf of Bothnia are extended, not only by the influx of sediment brought down by the rivers, but also by the elevation and consequent drying up of the bed of the sea, so a like combination of causes may, in modern times, have been extending the low tracts of land where marine shells and fossil bones occur in Siberia. Such a change in the physical geography of that region, implying a constant augmentation in the quantity of Arctic land, would, according to principles to be explained in the next chapter, tend to increase the severity of the winters. We may conclude, therefore, that before the land reached so far to the north, the temperature of the Siberian winter and summer was more nearly equalized, and a greater degree of winter's cold may, even more than a general diminution of the mean annual temperature, have finally contributed to the extermination of the mammoth and its contemporaries. On referring to the map, page 79, the reader will see how all the great rivers of Siberia flow at present from south to north, from temperate to Arctic regions, and they are all liable, like the Mackenzie, in North America, to remarkable floods in consequence of flowing in this direction. For they are filled with running water in their upper or northern course when completely frozen over for several hundred miles near their mouths, where they remain blocked up by ice for 6 months in every year. The descending waters, therefore, finding no open channel, rush over the ice, often changing their direction, and sweeping along forests and prodigious quantities of soil and gravel mixed with ice. Now the rivers of Siberia are among the largest in the world, the Yenisei having a course of 2,500, the Lena of 2,000 miles, so that we may easily conceive that the bodies of animals which fall into their waters may be transported to vast distances towards the Arctic Sea, and, before arriving there, may be stranded upon and often frozen into thick ice. Afterwards, when the ice breaks up, they may be floated still further towards the ocean, until at length they become buried in fluviatile and submarine deposits near the mouths of rivers. Humboldt remarks that near the mouths of the Lena a considerable thickness of frozen soil may be found at all seasons at a depth of a few feet, so that if a carcass be once embedded in mud and ice in such a region and in such a climate, its putrefaction may be arrested for indefinite ages. According to Prof. van Baer of St. Petersburg, the ground is now frozen permanently to the depth of 400 feet at the town of Yakutsk, in the western bank of the Lena, in latitude 62 degrees north, 600 miles distant from the Polar Sea. Mr. Hedenstrom tells us that, throughout a wide area in Siberia, the boundary cliffs of the lakes and rivers consist of alternate layers of earthy materials and ice in horizontal stratification. And Mr. Middendorf informed us in 1846 that, in his tour there 3 years before, he had bored into Siberia to the depth of 70 feet and, after passing through much frozen soil mixed with ice, had come down upon a solid mass of pure transparent ice, the thickness of which, after penetrating 2 or 3 yards, they did not ascertain. We may conceive, therefore, that even at the periods of the Mammoth, when the lowland of Siberia was less extensive towards the north, and consequently the climate more temperate than now, the cold may still have been sufficiently intense to cause the rivers flowing in their present direction to sweep down from the south to north the bodies of drowned animals, and there bury them in drift ice and frozen mud. If it be true that the carcass of the mammoth was embedded in pure ice, there are 2 ways in which it may have been frozen in. We may suppose the animal to have been overwhelmed by drift snow. I have been informed by Dr. Richardson that, in the northern parts of America, comprising regions now inhabited by many herbivorous quadrupeds, the drift snow is often converted into permanent glaciers. It is commonly blown over the edges of steep cliffs so as to form an inclined talus hundreds of feet high, and when a thaw commences, torrents rush from the land and throw down from the top of the cliff alluvial soil and gravel. This new soil soon becomes covered with vegetation and protects the foundation of snow from the rays of the sun. Water occasionally penetrates into the crevices and pores of the snow, but as it soon freezes again, it serves the more rapidly to consolidate the mass into a compact iceberg. It may sometimes happen that the cattle grazing in a valley at the base of such cliffs, on the borders of a sea or river, may be overwhelmed, and at length enclosed in solid ice, and then transported towards the polar regions. Or a herd of mammoths returning from their summer pastures in the north may have been surprised while crossing a stream by the sudden congelation of the waters. The missionary Huke relates, in his travels in Tibet in 1846, that, after many of his party had been frozen to death, they pitched their tents on the banks of the Muroi Usan, which lower down becomes the famous Blue River, and saw from their encampment, quote, "some black, shapeless objects ranged in file across the stream. As they advanced nearer, no change either in form or distinctness was apparent, nor was it till they were quite close that they recognized in them a troop of the wild oxen called yak by the Tibetans. There were more than 50 of them encrusted in the ice. No doubt they had tried to swim across at the moment of congelation, and had been unable to disengage themselves. Their beautiful heads, surmounted by huge horns, were still above the surface, but their bodies were held fast in the ice, which was so transparent that the position of the imprudent beast was easily distinguishable. They looked as if still swimming, but the eagles and ravens had pecked out their eyes." End quote. The foregoing investigations, therefore, lead us to infer that the mammoth and some other extinct quadrupeds, fitted to live in high latitudes, were inhabitants of northern Asia at a time when the geographical conditions and climate of that continent were different from the present. But the age of this fauna was comparatively modern in the Earth's history. It appears that when the oldest or Eocene tertiary deposits were formed, a warm temperature pervaded the European seas and lands. Shells of the genus Nautilus and other forms characteristic of tropical latitudes, fossil reptiles such as the crocodile, turtle, and tortoise, plants such as palms, some of them allied to the coconut, the screw pine, the custard apple, and the acacia, all lead to this conclusion. The flora and fauna were followed by those from the Miocene formation, in which indications of a southern but less tropical climate are detected. Finally, the Pliocene deposits, which come next in succession, exhibit in their organic remains a much nearer approach to the state of things now prevailing in corresponding latitudes. It was towards the close of this period that the seas of the northern hemisphere became more and more filled with floating icebergs often charged with erratic blocks, so that the waters of the atmosphere were chilled by the melting ice, and an Arctic fauna enabled for a time to invade the temperate latitudes both of North America and Europe. The extinction of a considerable number of land quadrupeds and aquatic mollusca was gradually brought about by the increasing severity of the cold, but many species survived this revolution in climate either by their capacity of living under a variety of conditions or by migrating for a time to more southern lands and seas. At length, by modifications in the physical geography of the northern regions and the cessation of floating ice on the eastern side of the Atlantic, the cold was moderated and a milder climate ensued, such as we now enjoy in Europe. Proofs from fossils in secondary and still older strata. A great interval of time appears to have elapsed between the formation of the secondary strata, which constitute the principal portion of the elevated land in Europe, and the origin of the Eocene deposits. If we examine the rocks from the chalk to the new red sandstone inclusive, we find many distinct assemblages of fossils entombed in them, all of unknown species, and many of them referable to genera and families now most abundant between the tropics. Among the most remarkable are reptiles of gigantic size, some of them herbivorous, others carnivorous, and far exceeding in size any now known even in the torrid zone. The genera are for the most part extinct, but some of them, as the crocodile and monitor, have still representatives in the warmer parts of the earth. Coral reefs were evidently numerous in the seas of the same periods, composed of species often belonging to genera now characteristic of a tropical climate. The number of large, chambered shells also, including the nautilus, leads us to infer an elevated temperature, and the associated fossil plants, although imperfectly known, tend to the same conclusion, the Cycadae constituting the most numerous family. But it is from the more ancient coal deposits that the most extraordinary evidence has been supplied in proof of the former existence of a very different climate, a climate which seems to have been moist, warm, and extremely uniform, in those very latitudes which are now the colder, and in regard to temperature the most variable regions of the globe. We learn from the researches of Adolphe Brongniart, Gilbert, and other botanists that in the flora of the Carboniferous era there was a great predominance of ferns, some of which were arborescent, as, for example, Calopterus, Protopterus, and Saronius. Nor can this be accounted for, as some have supposed, by the greater power which ferns possess of resisting maceration in water. This prevalence of ferns indicates a moist, equable, and temperate climate, and the absence of any severe cold, for such are the conditions which, at the present day, are found to be most favorable to that tribe of plants. It is only on the islands of the tropical oceans and of the southern temperate zone, such as Norfolk Island, Otaheite, and Sandwich Islands, Tristan da Cunha, and New Zealand, that we find any near approach to that remarkable preponderance of ferns which is characteristic of the Carboniferous flora. It has been observed that tree ferns and other forms of vegetation which flourished most luxuriantly within the tropics extend to a much greater distance from the equator in the southern hemisphere than in the northern, being found even as far as 46 degrees south latitude in New Zealand. There is little doubt that this is owing to the more uniform and moist climate occasioned by the greater proportional area of sea. Next to ferns and pines, the most abundant vegetable forms in the coal formation are the calamites, Lepidodendra, Sigillaria, and Stigmaria. These were formerly considered to be so closely allied to tropical genera, and to be so much greater in size than the corresponding tribes now inhabiting equatorial latitudes, that they were thought to imply an extremely hot as well as humid and equitable climate. But recent discoveries respecting the structure and relations of these fossil plants have shown that they deviated so widely from all existing types in the vegetable world that we have more reason to infer from this evidence a widely different climate in the Carboniferous era as compared to that now prevailing than a temperature extremely elevated. Palms, if not entirely wanting when the strata of the Carboniferous group were deposited, appear to have been exceedingly rare. The Coniferae, on the other hand, so abundantly met within the coal, resemble Araucariae in structure, a family of the fir tribe, characteristic at present of the milder regions of the southern hemisphere such as Chile, Brazil, New Holland, and Norfolk Island. Says M. Brongniart, quote, "In regard to the geographical extent of the ancient vegetation, it is not confined to a small space as to Europe, for example, for the same forms are met with again at great distances. Thus, the coal plants of North America are, for the most part, identical with those of Europe, and all belong to the same genera. Some specimens also from Greenland are referable to ferns analogous to those of our European coal mines." End quote. The fossil plants brought from Melville Island, although in a very imperfect state, have been supposed to warrant similar conclusions. And assuming that they agree with those of Baffin's Bay mentioned by M. Brongniart, how shall we explain the manner in which such a vegetation lived through an Arctic night of several months' duration? It may seem premature to discuss this question until a true nature of the fossil flora of the Arctic regions has been more accurately determined. Yet, as the question has attracted some attention, let us assume for a moment that the coal plants of Melville Island are strictly analogous to those of the strata of Northumberland. Would such a fact present an inexplicable enigma to the vegetable physiologist? Plants, it is affirmed, cannot remain in darkness, even for a week, without serious injury, unless in a torpid state, and if exposed to heat and moisture they cannot remain torpid, but will grow and must therefore perish. If, then, in the latitude of Melville Island, 75 degrees north, a high temperature and consequent humidity prevailed at that period, when we know the Arctic seas were filled with corals and large multilocular shells, how could plants of tropical forms have flourished? Is not the bright light of equatorial regions as indispensable a condition of their well-being as the sultry heat of the same countries? And how could they annually endure a night prolonged for 3 months? Now, in reply to this objection, we must bear in mind, in the first place, that, so far as experiments have been made, there is every reason to conclude that the range of intensity of light to which living plants can accommodate themselves is far wider than that of heat. No palms or tree ferns can live in our temperate latitudes without protection from the cold, but when placed in hothouses they grow luxuriantly, even under a cloudy sky, and where much light is intercepted by the glass and framework. At St. Petersburg, in latitude 60 degrees north, these plants have been successfully cultivated in hothouses, although there they must exchange the perpetual equinox of their native regions for days and nights which are alternately protracted to 19 hours and shortened to 5. How much further towards the pole they might continue to live, provided a due quantity of heat and moisture were supplied, has not yet been determined. But St. Petersburg is probably not the utmost limit, and we should expect that in latitude 65 degrees at least, where they would never remain 24 hours without enjoying the sun's light, they might still exist. It should also be borne in mind, in regard to tree ferns, that they grow in the gloomiest and darkest parts of the forests of warm and temperate regions, even extending to nearly the 46th degree of south latitude in New Zealand. In equatorial countries, says Humboldt, they abound chiefly in the temperate, humid, and shady parts of mountains. As we know, therefore, that elevation often compensates for the effect of latitude in the geographical distribution of plants, we may easily understand that a class of vegetables, which grows at a certain height in the torrid zone, would flourish on the plains at greater distances from the equator if the temperature, moisture, and other necessary conditions were equally uniform throughout the year. Nor must we forget that in all the examples above alluded to, we have been speaking of living species. But the coal plants were of perfectly distinct species, nay, few of them except the ferns and pines can be referred to genera or even families of the existing vegetable kingdom. Having a structure, therefore, and often a form which appears to the botanist so anomalous, they may also have been endowed with a different constitution, enabling them to bear a greater variation of circumstances in regard to light. We find that a particular species of plants and tree ferns requires at present different degrees of heat, and that some species can thrive only in the immediate neighborhood of the equator, others only a distance from it. In the same manner, the minimum of light, sufficient for the now existing species, cannot be taken as the standard for all analogous tribes that may ever have flourished on the globe. But granting that the extreme northern point to which a flora like that of the Carboniferous era could ever reach, maybe somewhere between the latitudes of 65 and 70 degrees, we should still have to inquire whether the vegetable remains might not have been drifted from thence by rivers and currents to the parallel of Melville Island or still further. In the northern hemisphere at present, we see that the materials for future beds of lignite and coal are becoming amassed in high latitudes far from the districts where the forests grew, and on the shores where scarcely a stunted shrub can now exist. The Mackenzie and other rivers of North America carry pines with their roots attached for many hundreds of miles towards the north into the Arctic Sea, where they are embedded in deltas, and some of them drifted still further by currents towards the pole. Before we can decide on this question of transportation, we must know whether the fossil coal plants occurring in high latitudes bear the marks of friction and having decayed previously to fossilization. Many appearances in our English coal fields certainly prove that the plants were not floated from great distances, for the outline of the stems of succulent species preserve their sharp angles, and others have their surface marked with the most delicate lines and streaks. Long leaves also are attached in many instances to the trunks or branches, and leaves, we know, in general, are soon destroyed when steeped in water, although ferns will retain their forms after an immersion of many months. It seems fair to presume that most of the coal plants grew upon the same land which supplied materials for the sandstones and conglomerates of the strata in which they are embedded. The coarseness of the particles of many of these rocks attests that they were not born from the very remote localities, and that there was land therefore in the vicinity wasting away by the action of moving waters. The progress also of modern discovery has led to the very general admission of the doctrine that the beds of coal have for the most part been formed in the remains of trees and plants that grew on the spot where the coal now exists, the land having been successfully submerged so that the covering of mud and sand was deposited upon accumulations of vegetable matter. That such has been the origin of some coal seams is proved by the upright position of fossil trees both in Europe and America, in which the roots terminate downwards in beds of coal. To return, therefore, from this digression, the flora of the coal appears to indicate a uniform and mild temperature in the air, while the fossils of the contemporaneous mountain limestone, comprising abundance of lamelliferous corals, large chambered cephalopods, and crinoideae, naturally lead us to infer a considerable warmth in the waters of the northern sea of the Carboniferous period. So also in regard to strata older than the coal. They contain in high northern latitudes mountain masses of corals which must have lived and grown on the spot, and large chambered univalves such as Orthocerata and Nautilus, all seeming to indicate, even in regions bordering on the Arctic Circle, the former prevalence of a temperature more elevated than that now prevailing. The warmth and humidity of the air and the uniformity of climate, both in the different seasons of the year and in different latitudes, appears to have been most remarkable when some of the oldest of the fossiliferous strata were formed. The approximation to a climate similar to that now enjoyed in these latitudes does not commence till the era of the formations termed Tertiary. And while the different Tertiary rocks were deposited in succession from the Eocene to the Pliocene, the temperatures seems to have been lowered and to have continued to diminish even after the appearance upon the Earth of a considerable number of the existing species, the cold reaching its maximum of intensity in European latitudes during the glacial epoch, or the epoch immediately antecedent to that in which all the species now contemporary with man were in being. Chapter 7. Farther examination of the question as to the assumed discordance of the ancient and modern causes of change. Causes of the vicissitudes in climate. As the proofs enumerated in the last chapter indicate that the Earth's surface has experienced great changes of climate since the deposition of the older sedimentary strata, we have next to inquire how such vicissitudes can be reconciled with the existing order of nature. The cosmogonist has availed himself of this, as of every obscure problem in geology, to confirm his views concerning a period when the planet was in a nascent or half-formed state, or when the laws of the animate and inanimate world differed essentially from those now established, and he has in this, as in many other cases, succeeded so far, as to divert attention from that class of facts which, if fully understood, might probably lead to an explanation of the phenomena. At first it was imagined that the Earth's axis had been for ages perpendicular to the plane of the ecliptic, so that there was a perpetual equinox and uniformity of seasons throughout the year. That the planet enjoyed this, quote, paradisiacal, unquote, state until the era of the Great Flood. But in that catastrophe, whether by the shock of a comet or some other convulsion, it lost its equal poise, and hence the obliquity of its axis. And with that, the varied seasons of the temperate zone and the long nights and days of the polar circles. When the progress of astronomical science had exploited this theory, it was assumed that the Earth at its creation was in a state of fluidity and red hot, and that ever since that era it had been cooling down, contracting its dimensions, and acquiring a solid crust, an hypothesis hardly less arbitrary, yet more calculated for lasting popularity, because by referring the mind directly to the beginning of things, it requires no support from observation, nor from any ulterior hypothesis. But if, instead of forming vague conjectures as to what might have been the state of the planet at the era of its creation, we fix our thoughts on the connection at present existing between climate and the distribution of land and sea, and then consider what influence former fluctuations in the physical geography of the Earth must have had on superficial temperature, we may perhaps approximate to a true theory. If doubts and obscurities still remain, they should be ascribed to our limited acquaintance with the laws of nature, not to revolutions in her economy. They should stimulate us to further research, not tempt us to indulge our fancies respecting the imaginary changes of internal temperature in an embryo world. Diffusion of heat over the globe. In considering the laws which regulate the diffusion of heat over the globe, we must be careful, as Humboldt well remarks, not to regard the climate of Europe as a type of the temperature which all countries placed under the same latitude enjoy. The physical sciences, observes the philosopher, always bear the impress of the places where they begin to be cultivated. And as, in geology, an attempt was at first made to refer all the volcanic phenomena to those of the volcanoes in Italy, so in meteorology, a small part of the Old World, the center of the primitive civilization of Europe, was for a long time considered a type to which the climate of all corresponding latitudes might be referred. But this region, constituting only 1/7 of the whole globe, proved eventually to be the exception to the general rule. For the same reason, we may warn the geologist to be on his guard and not hastily to assume that the temperature of the Earth in the present era is a type of that which most usually obtains, since he contemplates far mightier alterations in the position of the land and sea at different epochs than those which now cause the climate of Europe to differ from that of other countries in the same parallels. It is now well ascertained that the zones of equal warmth, both in the atmosphere and in the waters of the ocean, are neither parallel to the equator nor to each other. It is also known that the mean annual temperature may be the same in two places which enjoy very different climates, for the seasons may be nearly uniform or violently contrasted, so that the lines of equal winter temperature do not coincide with those of the equal annual heat or isothermal lines. The deviations of all these lines from the same parallel of latitude are determined by a multitude of circumstances, among the principal of which are the position, direction, and elevation of the continents and islands, the position and depths of the sea, and the direction of currents and of winds. On comparing the two continents of Europe and America, it is found that places in the same latitudes have sometimes a mean difference of temperature amounting to 11 degrees, or even in a few cases to 17 degrees Fahrenheit, and some places on the two continents, which have the same mean temperature, differ from 7 to 17 degrees in latitude. Thus, Cumberland House in North America, having the same latitude, 54 degrees north, as the city of York in England, stands on the isothermal line of 32 degrees, which in Europe rises to the North Cape, in latitude 71 degrees, but its summer heat exceeds that of Brussels or Paris. The principal cause of greater intensity of cold in corresponding latitudes of North America, as contrasted with Europe, is the connection of America with the polar circle by a large tract of land, some of which is from 3,000 to 5,000 feet in height, and on the other hand, the separation of Europe from the Arctic Circle by an ocean. The ocean has a tendency to preserve everywhere a mean temperature which it communicates to the contiguous land, so that it tempers the climate, moderating alike in excess of heat or cold. The elevated land, on the other hand, rising to the colder regions of the atmosphere, becomes a great reservoir of ice and snow, arrests, condenses, and congeals vapor, and communicates its cold to the adjoining country. For this reason, Greenland, forming part of a continent which stretches northward to the 82nd degree of latitude, experiences under the 60th parallel a more rigorous climate than Lapland under the 72nd parallel. But if land be situated between the 40th parallel and the equator, it produces, unless it be of extreme height, exactly the opposite effect. For it then warms the tracts of land or sea that intervene between it and the polar circle. For the surface being in this case exposed to the vertical or nearly vertical rays of the sun, absorbs a large quantity of heat, which it diffuses by radiation into the atmosphere. For this reason, the western parts of the old continent derive warmth from Africa, quote, which, like an immense furnace, distributes its heat to Arabia, to Turkey and Asia, and to Europe, end quote. On the contrary, the northeastern extremity of Asia experiences in the same latitude extreme cold, for it has land on the north between the 60th and 70th parallel, while to the south it is separated from the equator by the Pacific Ocean. In consequence of the more equal temperature of the waters of the ocean, the climate of islands and of coasts differs essentially from that of the interior of the continents, the more maritime climate being characterized by mild winters and more temperate summers, for the sea breezes moderate the cold of winter as well as the heat of summer. When, therefore, we trace round the globe those belts in which the mean annual temperature is the same, we often find great differences in climate. For there are insular climates, in which the seasons are nearly equalized, and excessive climates, as they have been termed, where the temperature of winter and summer is strongly contrasted. The whole of Europe, compared to the eastern parts of America and Asia, has an insular climate. The northern part of China and the Atlantic region of the United States exhibit excessive climates. We find at New York, says Humboldt, the summer of Rome and winter of Copenhagen, at Quebec, the summer of Paris and the winter of Petersburg. At Pekin, in China, where the mean temperature of the year is that of the coast of Brittany, the scorching heats of summer are greater than at Cairo, and the winters as rigorous as at Uppsala. If lines be drawn round the globe through all those places which have the same winter temperature, they are found to deviate from the terrestrial parallels much farther than the lines of equal mean annual heat. The lines of equal winter in Europe, for example, are often curved so as to reach parallels of latitude 9 or 10 degrees distant from each other, whereas the isothermal lines, or those passing through places having the same mean annual temperature, differ only from 4 to 5 degrees in Europe. Influence of currents and drift ice on temperature. Among other influential causes, both of remarkable diversity in the mean annual heat and of unequal division of heat in the different seasons, are the direction of currents and the accumulation and drifting of ice in high latitudes. The temperature of the Lagulas current is 10 or 12 degrees Fahrenheit above that of the sea at the Cape of Good Hope, for it derives the greater part of its waters from the Mozambique Channel and southeast coast of Africa, and from regions in the Indian Ocean much nearer the line and much hotter than the Cape. An opposite effect is produced by the equatorial current, which crosses the Atlantic from Africa to Brazil, having a breadth varying from 160 to 450 nautical miles. Its waters are cooler by 3 or 4 degrees Fahrenheit than those of the ocean under the line, so that it moderates the heat of the tropics. But the effects of the Gulf Stream on the climate of the North Atlantic Ocean are far more remarkable. This most powerful of known currents has its source in the Gulf or Sea of Mexico, which, like the Mediterranean or other close seas in temperate or low latitudes, is warmer than the open ocean in the same parallels. The temperature of the Mexican Sea in summer is, according to Rennell, 86 degrees Fahrenheit, or at least 7 degrees above that of the Atlantic in the same latitude. From this great reservoir or cauldron of warm water, a constant current pours forth through the Straits of Bahama at the rate of 3 or 4 miles an hour. It crosses the ocean in a northeasterly direction, skirting the Great Bank of Newfoundland, where it still retains a temperature of 8 degrees above that of the surrounding sea. It reaches the Azores in about 78 days, after flowing nearly 3,000 geographical miles, and from thence it sometimes extends its course 1,000 miles further, so as to reach the Bay of Biscay, still retaining an excess of 5 degrees above the mean temperature of that sea. As it has been known to arrive there in the months of November and January, it may tend greatly to moderate the cold of winter in countries in the west of Europe. There is a large tract in the center of the North Atlantic, between the parallels of 33 and 45 degrees north latitude, which Rennell calls the, quote, recipient of the Gulf water, end quote. The great part of it is covered by the weed called Sargassum baciferum, which the current floats in abundance from the Gulf of Mexico. This mass of water is nearly stagnant, is warmer by 7 or 10 degrees than the waters of the Atlantic, and may be compared to the fresh water of a river overflowing the heavier salt water of the sea. Rennell estimates the area of the, quote, recipient, unquote, together with that covered by the main current, as being 2,000 miles in length from east to west and 350 in breadth from north to south, which he remarks is a larger area than that of the Mediterranean. The heat of this great body of water is kept up by the incessant and quick arrivals of fresh supplies of warm water from the south. And there can be no doubt that the general climate of parts of Europe and America is materially affected by this cause. It is considered probable by Scoresby that the influence of the Gulf Stream extends even to the sea near Spitzbergen, where its waters may pass under those of melted ice, for it has been found that in the neighborhood of Spitzbergen, the water is warmer by 6 or 7 degrees at the depth of 100 to 200 fathoms than at the surface. This might arise from the known law that fresh water passes the point of greatest density when cooled down below 40 degrees, and between that and the freezing point expands again. The water of melted ice might be lighter, both as being fresh, having lost its salt in the decomposing process of freezing, and because its temperature is nearer the freezing point than the inferior water of the Gulf Stream. The great glaciers generated in the valleys of Spitzbergen, in the 79 degree of north latitude, are almost all cut off at the beach, being melted by the feeble remnant of heat still retained by the Gulf Stream. In Baffin's Bay, on the contrary, on the west coast of Old Greenland, where the temperature of the sea is not mitigated by the same cause, and where there is no warmer undercurrent, the glaciers stretch out from the shore and furnish repeated crops of mountainous masses of ice which float off into the ocean. The number and dimension of these bergs is prodigious. Captain Sir John Ross saw several of them together in Baffin's Bay, aground in water 1,500 feet deep. Many of them are driven down into Hudson's Bay, and accumulating there, diffuse excessive cold water over the neighboring continent, so that Captain Franklin reports that the mouth of Hayes River, which lies in the same latitude as the north of Prussia or the south of Scotland, ice is found everywhere in digging wells, in summer at the depth of 4 feet. Other bergs have been occasionally met with, at midsummer, in a state of rapid thaw as far south as latitude 40 degrees and longitude about 60 degrees west, where they cool the water sensibly to the distance of 40 or 50 miles around, the thermometer sinking sometimes 17 degrees or even 18 degrees Fahrenheit in their neighborhood. It is a well-known fact that every 4 or 5 years a large number of icebergs floating from Greenland double Cape Langaness and are stranded on the west coast of Iceland. The inhabitants are then aware that their crops of hay will fail in consequence of fogs which are generated almost incessantly. And the dearth of food is not confined to the land, for the temperature of the water is so changed that the fish entirely desert the coast. Difference of climate of the northern and southern hemispheres. When we compare the climate of the northern and southern hemispheres, we obtain still more instruction in regard to the influence of the distribution of land and sea on climate. The dry land in the southern hemisphere is to that of the northern in the ratio only of 1 to 3, excluding from our consideration that part which lies between the pole and 78 degrees of south latitude, which has hitherto proved inaccessible. And whereas in the northern hemisphere, between the pole and the 30th parallel of north latitude, the land and sea occupy nearly equal areas, the ocean in the southern hemisphere covers no less than 15 parts in 16 of the entire space included between the Antarctic Circle and the 30th parallel of south latitude. This great extent of sea gives a particular character to climate south of the equator, the winters being mild and the summers cool. Thus, in Van Diemen's Land, corresponding nearly in latitude to Rome, the winters are more mild than at Naples, and the summers not warmer than those at Paris, which is 7 degrees further from the equator. The effects on animal and vegetable life are remarkable. Captain King observed large shrubs of fuchsia and veronica, which in England are treated as tender plants, thriving and in full flower in Tierra del Fuego with the temperature at 36 degrees. He also states that hummingbirds were seen sipping the sweets of the flowers, quote, after 2 or 3 days of constant rain, snow, and sleet, during which time the thermometer had been at the freezing point, end quote. Mr. Darwin also saw parrots feeding on the seeds of a tree called the winter's bark south of latitude 55 degrees near Cape Horn. So the orchideous plants, which are parasitical on trees and are generally characteristic of the tropics, advanced to the 38th and 42nd degree of south latitude and even beyond the 45th degree in New Zealand, where they were found by Forster. In South America also, arborescent grasses abound in the dense forests of Chile in latitude 42 degrees south, where, quote, they entwine the trees into one entangled mass to the height of 30 or 40 feet above the ground. Palm trees in the same manner of the globe grow in latitude 37 degrees, an arborescent grass very like the bamboo in 40 degrees, and another closely allied kind, of great length but not erect, even as far south as 45 degrees, end quote. It has long been supposed that the general temperature of the southern hemisphere was considerably lower than that of the northern, and that the difference amounted to at least 10 degrees Fahrenheit. Baron Humboldt, after collecting and comparing a great number of observations, came to the conclusion that even a much larger difference existed, but that none was to be observed within the tropics, and only a small difference as far as the 35th and 40th parallel. Captain Cook was of opinion that the ice of the Antarctic predominated greatly over that of the Arctic region, that encircling the southern pole came nearer to the equator by 10 degrees than the ice around the North Pole. All the recent voyages of discovery have tended to confirm this opinion, although Captain Weddell penetrated, in 1823, 3 degrees further south than Captain Cook, reaching latitude 74 degrees 15 minutes south, longitude 34 degrees 17 minutes west, and Sir James Ross, in 1842, arrived at latitude 78 degrees 10 minutes south, as high a latitude, within 3 degrees, as the farthest point attained by Captain Parry in the Arctic Circle, or latitude 81 degrees 12 minutes north. The description given by ancient as well as modern navigators of the sea and land in high southern latitudes clearly attests the greater severity of the climate as compared to Arctic regions. In Sandwich Land, in latitude 59 degrees south, or in nearly the same parallel as the north of Scotland, Captain Cook found the whole country, from the summits of the mountains down to the very brink of the sea cliffs, quote, covered many fathoms thick with everlasting snow, end quote. And this on the 1st of February, the hottest time of the year. And what is still more astonishing, in the islands of South Georgia, which is in the 54 degrees south latitude, or the same parallel as Yorkshire, the line of perpetual snow descends to the level of the ocean. When we consider this fact, and then recollect that the highest mountains in Scotland, which ascend to an elevation of nearly 5,000 feet, and are 4 degrees farther to the north, do not attain the limit of perpetual snow on our side of the equator, we learn that latitude is one only of many powerful causes which determine the climate of particular regions of the globe. Captain Sir James Ross, in his exploring expedition in 1841-3, found that the temperature south of the 60th degree of latitude seldom rose above 32 degrees Fahrenheit. During the 2 summer months of the year 1841, January and February, the range of the thermometer was between 11 and 32 degrees Fahrenheit, and scarcely rose above the freezing point. The permanence of snow in the southern hemisphere is in this instance partly due to the floating ice, which chills the atmosphere and condenses the vapor, so that in summer the sun cannot pierce through the foggy air. But beside the abundance of land which covers the sea to the south of Georgia and Sandwich Land, we may also, as Humboldt suggests, ascribe the cold to those countries in part to the absence of land between them and the tropics. If Africa and New Holland extend farther to the south, a diminution of ice would take place in consequence of the radiation of heat from these continents during summer, which would warm the contiguous sea and rarefy the air. The heated aerial currents would then ascend and flow more rapidly towards the South Pole and moderate the winter. In confirmation of these views, it is stated that the ice, which extends as far as the 68 degree and 71 degree of south latitude, advances more towards the equator whenever it meets an open sea. That is, where the extremities of the present continents are not opposite to it, and the circumstance seems explicable only on the principle above alluded to of the radiation of heat from the lands so situated. The cold of the Antarctic regions was conjectured by Cook to be due to the existence of a large tract of land between the 70th degree of south latitude and the pole. The justness of these and other speculations of the great navigator have since been singularly confirmed by the investigation made by Sir James Ross in 1841. He found Victoria Land, extending from 71 degrees to 79 degrees south latitude, skirted by a great barrier of ice, the height of the land ranging from 4,000 to 14,000 feet. The whole entirety covered with snow, except a narrow ring of black earth surrounding it, the huge crater of the active volcano of Mount Erebus, rising 12,400 feet above the eye level of the sea. The position of a mountainous territory of such altitude, so near the pole and so obviously a source of intense cold, fully explains why Graham's and Enderby's land, discovered by Captain Biscoe in 1831-2, between latitude 64 degrees and 68 degrees south, presented a most wintry aspect, covered even in summer with ice and snow, and nearly destitute of animal life. In corresponding latitudes of the northern hemisphere, we not only meet the herds of wild herbivorous animals, but with land which man himself inhabits, and where he has even built ports and inland villages. The distance to which icebergs float from the polar regions on the opposite sides of the line is, as might have been anticipated, very different. Their extreme limit on the northern hemisphere is latitude 40 degrees, as before mentioned, and they are occasionally seen in latitude 42 degrees north near the termination of the Great Bank of Newfoundland, and at the Azores, latitude 42 degrees north, to which they are sometimes drifted from Baffin's Bay. But in the other hemisphere they have been seen, within the last few years, at different points off the Cape of Good Hope between latitude 36 degrees and 39 degrees. One of these, see figure 2, was 2 miles in circumference and 150 feet high, appearing like chalk when the sun was obscured, and having the luster of refined sugar when the sun was shining on it. Others have rose from 250 to 300 feet above the level of the sea, and were therefore of great volume below, since it was ascertained by experiments on the buoyancy of ice floating in seawater that for every cubic foot seen above, there must at least be 8 cubic feet below water. If ice islands from the North Polar regions floated as far, they might reach Cape St. Vincent, and there, being drawn by the current that always sets in from the Atlantic through the Straits of Gibraltar, be drifted into the Mediterranean, so that the serene sky of that delightful region might soon be deformed by clouds and mists. Before the amount of difference between the temperature of the two hemispheres was ascertained, it was referred by many astronomers to the precession of the equinoxes, or the acceleration of the Earth's motion in its perihelion, in consequence of which the spring and summer of the southern hemisphere are now shorter by nearly 8 days than those seasons north of the equator. But Sir J. Herschel reminds us that the excess of 8 days in the duration of the sun's presence in the northern hemisphere is not productive of an excess of annual light and heat, since, according to the laws of elliptical motion, it is demonstrable that whatever the ellipticity of the Earth's orbit, the two hemispheres must receive equal absolute quantities of light and heat per annum, the proximity of the sun in perigee exactly compensating the effect of its swifter motion. Humboldt, however, observed that there must be a greater loss of heat by radiation in the southern hemisphere during a winter longer by 8 days than that on the other side of the equator. Perhaps no very sensible effect may be produced by this source of disturbance, yet the geologist should bear in mind that to a certain extent it operates alternately on each of the two hemispheres for a period of upwards of 10,000 years, dividing unequally the times during which the annual supply of solar light and heat is received. This cause may sometimes tend to counterbalance inequalities of temperature resulting from other far more influential circumstances, but on the other hand, it must sometimes tend to increase the extreme of deviation arising from particular combinations of causes. But whatever may be at present the inferiority of heat in the temperate and frigid zones south of the line, it is quite evident that the cold would be far more intense if there happened, instead of open sea, to be tracts of elevated land between the 55th and 70th parallel, and, on the other hand, the cold would be moderated if there were more land between the line and the 45th degree of south latitude. Changes in the position of land and sea may give rise to vicissitudes in climate. Having offered these brief remarks on the diffusion of heat over the globe in the present state of the surface, I shall now proceed to speculate on the vicissitudes of climate which must attend those endless variations in the geographical features of our planet which are contemplated in geology. That our speculations may be confined within the strict limits of analogy, I shall assume, first, that the proportion of dry land to sea continues always the same. Secondly, that the volume of land rising above the level of the sea is a constant quantity, and not only that its mean, but that its extreme height is liable only to trifling variations. Thirdly, that both the mean and extreme depth of the sea are invariable, and fourthly, it may be consistent with due caution to assume that the grouping together of land and continents is a necessary part of the economy of nature. For it is possible that the laws which govern the subterranean forces, and which act simultaneously along certain lines, cannot but produce, at every epoch, continuous mountain chains, so that the subdivision of the whole land into innumerable islands may be precluded. If it be objected that the maximum elevation of land and depth of sea are probably not constant, nor the gathering together of all the land in certain parts, nor even perhaps the relative extent of land and water, I reply that the arguments about to be adduced will be strengthened if, in these peculiarities of the surface, there be considerable deviations from the present type. If, for example, all other circumstances being the same, the land is at one time more divided into islands than at another, a greater uniformity of climate might be produced, the mean temperature remaining unaltered. Or if, at another era, there were mountains higher in the Himalaya, these, when placed in high latitudes, would cause a greater excess of cold. Or if we suppose that at certain periods no chain of hills in the world rose beyond the height of 10,000 feet, a greater heat might have prevailed than is compatible with the existence of mountains thrice that elevation. However constant may be the relative proportion of sea and land, we know that there is annually some small variation in their respective geographical positions, and that in every century the land is in somewhat parts raised, and in others depressed on every level, and so likewise is the bed of the sea. By these and other ceaseless changes, the configuration of the Earth's surface has been remodeled again and again, since it was the habitation of organic beings, and the bed of the ocean has been lifted up to the height to make some of the loftiest mountains. The imagination is apt to take alarm when called upon to admit the formation of such irregularities in the crust of the earth, after it had once become the habitation of living creatures. But if time be allowed, the operation need not subvert the ordinary repose of nature, and the result is in a general view insignificant, if we consider how slightly the highest mountain chains cause our globe to differ from a perfect sphere. Chimborazo, though it rises to more than 21,000 feet above the sea, would be represented on a globe of about 6 feet in diameter by a grain of sand less than 1/20th of an inch in thickness. The superficial inequalities of the Earth, then, may be deemed minute in quality, and their distribution to any particular epoch must be regarded in geology as temporary peculiarities, like the height and outline of the cone of Vesuvius in the interval between two eruptions. But although, in reference to the magnitude of the globe, the unevenness of the surface is so unimportant, it is on the position and direction of these small inequalities that the state of the atmosphere and both the local and general climate are mainly dependent. Before considering the effect which a material change in the distribution of land and sea must occasion, it may be well to remark how greatly organic life may be affected by these minor variations, which need not in the least degree alter the general temperature. Thus, for example, if we suppose by a series of convulsions a certain part of Greenland to become sea, and in compensation a tract of land to rise and connect Spitzbergen with Lapland, an accession not greater in amount than one which the geologist can prove to have occurred in certain districts bordering the Mediterranean within a comparatively modern period. This altered form of the land might cause an interchange between the climate of certain parts of North America and of Europe, which lie in corresponding latitudes. Many European species of plants and animals would probably perish in consequence because the mean temperature would be greatly lowered, and others would fall in America because it would there be raised. On the other hand, in places where the mean annual heat remained unaltered, some species which flourish in Europe, where the seasons are more uniform, would be unable to resist the greater heat of North American summer or the intenser cold of the winter, while others now fitted by their habits for the great contrast of the American seasons would not be fitted for the insular climate of Europe. The vine, for example, according to Humboldt, can be cultivated with advantage 10 degrees farther north in Europe than in North America. Many plants endure severe frost, but cannot ripen their seeds without a certain intensity of summer heat and a certain quantity of light. Others cannot endure a similar intensity either of heat or cold. It is now established that many of the existing species of animals have survived great changes in the physical geography of the globe. If such species be termed modern, in comparison to races which preceded them, their remains, nevertheless, enter into submarine deposits many hundred miles in length, and which have since been raised from the deep to no considerable altitude. When, therefore, it is shown that changes in the temperature of the atmosphere may be the consequence of such physical revolutions of the surface, we ought no longer to wonder that we find the distribution of existing species to be local in regard to longitude as well as latitude. If all species were now, by an exertion of creative power, to be diffused uniformly throughout those zones where there is an equal degree of heat, and in all respects a similarity of climate, they would begin from this moment to depart more and more from their original distribution. Aquatic and terrestrial species would be displaced, as Hooke long ago observed, so often as land and water exchange places. And there would also, by the formation of new mountains and other changes, be transpositions of climate contributing, in the manner before alluded to the local extermination of species. If we now proceed to consider the circumstances required for a general change of temperature, it will appear from the facts and principles already laid down that whenever a greater extent of high land is collected in the polar regions, the cold will augment, and the same result will be produced when there is more sea between or near the tropics, while on the contrary, so often as above conditions are reversed, the heat will be greater. See figures 5 and 6. If this be admitted, it will follow that unless the superficial inequalities of the Earth be fixed and permanent, there must be never-ending fluctuations in the mean temperature of every zone, and that the climate of one era can no more be a type of every other than is one of our 4 seasons of all the rest. It has been well said that the Earth is covered by an ocean, in the midst of which are 2 great islands and many smaller ones. For the whole of the continents and islands occupy an area scarcely exceeding 1/4 of the whole superficies of the spheroid. Now, according to this analogy, we may fairly speculate on the probability that there would not be usually, at any given epoch in the past, more than about 1/4 dry land in a particular region. As, for example, near the poles or between them and the 75th parallels of north and south latitude. If, therefore, at present there should happen to be in both these quarters of the globe much more than this average proportion of land, some of it in the Arctic region being above 5,000 feet in height, and if in Antarctic latitudes a mountainous country has been found varying from 4,000 to 14,000 feet in height, this alone affords ground for concluding that, in the present state of things, the mean heat of the climate is below that which the Earth's surface, in its more ordinary state, would enjoy. This presumption is heightened when we reflect on the results of the recent soundings made by Sir James Ross in the Southern Ocean and continued for 4 successive years, ending 1844, which seem to prove that the mean depth of the Atlantic and Pacific is as great as Laplace and other eminent astronomers had imagined. For then we might look not only for more than 2/3 sea in the frigid zones, but for water of great depth, which could not readily be reduced to the freezing point. The same opinion is confirmed when we compare the quantity of land lying between the poles and the 30th parallels of north and south latitude with the quantity placed between those parallels and the equator, for it is clear that we have at present not only more than the usual degree of cold in the polar regions, but also less than the average quantity of heat within the tropics. Position of land and sea which might produce the extreme of cold of which the Earth's surface is susceptible. To simplify our view of the various changes in climate, which different combinations of geographical circumstances may produce, we shall first consider the conditions necessary for bringing about the extremes of cold, or what would have been termed in the language of the old writers the winter of the "great year," or geological cycle, and afterwards the conditions requisite to produce the maximum heat, or the summer of the same year. To begin with the northern hemisphere, let us suppose those hills of the Italian peninsula and of Sicily, which are of comparatively modern origin and contain many fossil shells identical with living species, to subside again into the sea, from which they have been raised, and that the extent of land of equal area and height, varying from 1 to 3,000 feet, should rise up in the Arctic Ocean between Siberia and the North Pole. In speaking of such changes, I shall not allude to the manner in which I conceive it possible that they may be brought about, nor for the time required for their accomplishment, reserving for a future occasion not only the proofs that revolutions of equal magnitude have taken place, but that analogous operations are still in gradual progress. The alteration now supposed in the physical geography of the northern regions, which would cause additional snow and ice to accumulate where now there is usually an open sea, and the temperature of the greater part of Europe would be somewhat lowered, so as to resemble more nearly that of the corresponding latitudes of North America. Or in other words, it might be necessary to travel about 10 degrees farther south in order to meet with the same climate which we now enjoy. No compensation would be derived from the disappearance of land in the Mediterranean countries, but the contrary, since the mean heat of the soil in those latitudes probably exceeds that which would belong to the sea, by which we imagine it to be replaced. But let the configuration of the surface be still farther varied, and let some large district within or near the tropics, such as Brazil, with its plains and hills of moderate height, be converted into sea, while lands of equal elevation and extent rise up in the Arctic Circle. From this change there would, in the first place, result a sensible diminution of temperature near the tropic, for the Brazilian soil would no longer be heated by the sun, so that the atmosphere would be less warm and also the neighboring Atlantic. On the other hand, the whole of Europe, Northern Asia, and North America would be chilled by the enormous quantity of ice and snow thus generated on the new Arctic continent. If, as we have already seen, there are now some points in the southern hemisphere where snow is perpetual down to the level of the sea in latitudes as low as central England, such might assuredly be the case throughout the great part of Europe under the change of circumstances above supposed. And if at present the extreme range of drifted icebergs is the Azores, they might easily reach the equator after the assumed alteration. But to pursue the subject still further, let the Himalaya Mountains with the whole of Hindustan sink down, and their place be occupied by the Indian Ocean, while an equal extent of territory and mountains of the same vast height rise up between North Greenland and the Orkney Islands. It seems difficult to exaggerate the amount to which the climate of the northern hemisphere would then be cooled. But the refrigeration brought about at the same time in the southern hemisphere would be nearly equal, and the difference of temperature between the Arctic and equatorial latitudes would not be much greater than at present. For no important disturbance can occur in the climate of a particular region without its immediately affecting all other latitudes, however remote. The heat and cold which surround the globe are in a state of constant and universal flux and reflux. The heated and rarefied air is always rising and flowing from the equator towards the poles in the higher regions of the atmosphere, while in the lower, the colder air is flowing back to restore the equilibrium. That this circulation is constantly going on in the aerial currents is not disputed. It is often proved by the opposite course of the clouds at different heights, and the fact that has been further illustrated in a striking manner by two recent events. The trade wind continually blows with great force from the island of Barbados to that of St. Vincent. Notwithstanding such, during the eruption of the volcano in the island of St. Vincent in 1812, ashes fell in profusion from a great height in the atmosphere upon Barbados. In like manner, during the great eruption of Sumbawa in 1815, ashes were carried to the islands of Amboyna and Banda, which last is about 800 miles east from the site of the volcano. Yet the southeast monsoon was then at its height. This apparent transposition of matter against the wind confirmed the opinion of the existence of a countercurrent in the higher regions, which had previously rested on theoretical conclusions only. That a corresponding interchange takes place in the seas is demonstrated, according to Humboldt, by the cold which is found to exist at great depths within the tropics, and among other proofs may be mentioned the mass of warmer water which the Gulf Stream is constantly bearing northwards, while a cooler current flows from the north along the coast of Greenland and Labrador and helps restore the equilibrium. Currents of colder and therefore specifically heavier water pass from the poles towards the equator, which cool the inferior parts of the ocean, so that the heat of the torrid zone and the cold of the polar circle balance each other. The refrigeration, therefore, of the polar regions, resulting from the supposed alteration in the distribution of land and sea, would be immediately communicated to the tropics, and from them its influence would extend to the Antarctic Circle, where the atmosphere and the ocean would be cooled so that ice and snow would augment. Although the mean temperature of higher latitudes in the southern hemisphere is, as before stated, for the most part, lower than that of the same parallels in the northern, yet for a considerable space on each side of the line, the mean annual heat of the waters is found to be the same in corresponding parallels. If, therefore, by the new position of the land, the formation of icebergs had become of common occurrence in the northern temperate zone, and if these were frequently drifted as far as the equator, the same degree of cold which they generated would immediately be communicated as far as the Tropic of Capricorn, and from thence to the lands or ocean to the south. The freedom, then, of the circulation of heat and cold from pole to pole being duly considered, it will be evident that the mean temperature which may prevail at the same point at two distinct periods may differ far more widely than that of any two points in the same parallels of latitude at one and the same period. For the range of temperature, or in other words, the curvature of the isothermal lines in a given zone, and at a given period, must always be circumscribed within narrow limits, the climate of each place in the zone being controlled by the combined influence of the geographical peculiarities of all other parts of the earth. Whereas, if we compare the state of things at two distinct and somewhat distant epochs, a particular zone may at one time be under the influence of one class of disturbing causes, and at another time may be affected by an opposite combination. The lands, for example, to the north of Greenland cause the present climate of North America to be colder than that of Europe in the same latitudes. But the excess of cold is not so great as it would have been if the Western Hemisphere had been entirely isolated or separated from the Eastern like a distinct planet. For not only does the refrigeration produced by Greenland chill to a certain extent the atmosphere of Northern and Western Europe, but the mild climate of Europe reacts also upon North America and moderates the chilling influence of the adjoining polar lands. To return to the state of the Earth after the changes above supposed, we must not omit to dwell on the important effects to which a wide expanse of perpetual snow would give rise. It is probable that nearly the whole sea, from the poles to the parallels of 45 degrees, would be frozen over, for it is well known that the immediate proximity of land is not essential to the formation and increase of field ice, provided there be in some part of the same zone a sufficient quantity of glaciers generated on or near the land to cool down the sea. Captain Scoresby, in his account of the Arctic regions, observes that when the sun's rays, quote, fall upon the snow-clad surface of the ice or land, they are in a great measure reflected without producing any material elevation of temperature. But when they impinge on the black exterior of a ship, the pitch on the side occasionally becomes fluid while ice is rapidly generated at the other. End quote. Now, field ice is almost always covered with snow, and thus not only land as extensive as our existing continents, but immense tracts of sea in the frigid and temperate zones might present a solid surface covered with snow and reflecting the sun's rays for the greater part of the year. Within the tropics, moreover, where the ocean now predominates, the sky would no longer be serene and clear as in the present era, but the masses of floating ice would cause quick condensation of vapor so that fogs and clouds would deprive the vertical rays of the sun of half their power. The whole planet, therefore, would receive annually a smaller portion of the solar influence, and the external crust would part, by radiation, with some of the heat which had been accumulated in it during a different state of the surface. This heat would be dissipated in the spaces surrounding our atmosphere, which, according to the calculations of M. Fourier, have a temperature much inferior to that of freezing water. After the geographical revolution above assumed, the climate of equinoctial lands might be brought at last to resemble that of the present temperate zone, or perhaps be far more wintry. They who should then inhabit such small isles and coral reefs as are now seen in the Indian Ocean and South Pacific would wonder that zoophytes of large dimensions had once been so prolific in their seas, or if, perchance, they found the wood and fruit of the coconut tree, or the palm silicified by the waters of some ancient mineral spring, or encrusted with calcareous matter, they would muse on the revolutions which had annihilated such genera and replaced them by the oak, the chestnut, and the pine. With equal admiration they would compare the skeletons of their small lizards with the bones of fossil alligators and crocodiles more than 20 feet in length, which at a former epoch had multiplied between the tropics. And when they saw a pine included in an iceberg drifted from latitudes which we now call temperate, they would be astonished at the proof thus afforded that forests had once grown where nothing could be seen in their own times but a wilderness of snow. If the reader hesitate to suppose so extensive an alteration of temperature as the probable consequence of geographical changes, confined to one hemisphere, he should remember how great are the local anomalies in climate now resulting from the peculiar distribution of land and sea in certain regions. Thus, in the island of South Georgia, before mentioned, page 98, Captain Cook found the everlasting snows descending to the level of the sea between latitude 54 degrees and 55 degrees south. No trees or shrubs were to be seen, and in summer a few rocks only, after a partial melting of the ice and snow, were scantily covered with moss and tufts of grass. If such a climate can now exist at the level of the sea in a latitude corresponding to that of Yorkshire, in spite of all those equalizing causes before enumerated, by which the mixture of the temperatures of distant regions is facilitated throughout the globe, what rigors might we not anticipate in a winter generated by the transfer of the mountains of India to our Arctic Circle? But we have still to contemplate the additional refrigeration which might be effected by changes in the relative position of land and sea in the southern hemisphere. If the remaining continents were transferred from the equatorial and contiguous latitudes to the south polar regions, the intensity of cold produced might, perhaps, render the globe uninhabitable. We are too ignorant of the laws governing the direction of subterranean forces to determine whether such a crisis be within the limits of possibility. At the same time, it may be observed that no distribution of land can well be imagined more irregular, or as it were capricious, than that which now prevails, For at present the globe may be divided into two equal parts, in such manner that one shall contain less water than land, see figures 3 and 4, and what is still more extraordinary, on comparing the extratropical lands in the northern and southern hemispheres, the lands in the northern are found to be to those in the southern in the proportion of 13 to 1. To imagine all the lands, therefore, in high, and all the sea in low latitudes, as delineated in figure 6, would scarcely be a more anomalous state of the surface. Position of land and sea which might give rise to the extreme of heat. Let us now turn from the contemplation of the winter of the "great year," and consider the opposite train of circumstances which would bring on the spring and summer. To imagine all the lands to be collected together in equatorial latitudes, and a few promontories only to project beyond the 30th parallel, as represented in the annexed maps, would be undoubtedly to suppose an extreme result of geological change. But if we consider a mere approximation to such a state of things, it would be sufficient to cause a general elevation of temperature. Nor can it be regarded as a visionary idea that, amidst the revolutions of the earth's surface, the quantity of land should, at certain periods, have been simultaneously lessened in the vicinity of both poles and increased within the tropics. We must recollect that even now it is necessary to ascend to the height of 15,000 feet in the Andes under the line, and in the Himalaya mountains, which are without the tropic, to 17,000 feet, before we reach the limit of perpetual snow. On the northern slope, indeed, of the Himalaya range, where the heat radiated from a great continent moderates the cold, there are meadows and cultivated land at an elevation equal to the height of Mont Blanc. If then there were no Arctic lands to chill the atmosphere and freeze the sea, and if the loftiest chains were near the line, it seems reasonable to imagine that the highest mountains might be clothed with a rich vegetation to their summits, and that nearly all signs of frost would disappear from the earth. When the absorption of the solar rays was in no region impeded, even in winter, by a coat of snow, the mean heat of the earth's crust would augment to considerable depths, and springs, which we know to be in general an index of the mean temperature of the climate, would be warmer in all latitudes. The waters of lakes, therefore, and rivers would be much hotter in winter, and would be never chilled in summer by melted snow and ice. A remarkable uniformity of climate would prevail amid the archipelagos of the temperate and polar oceans, where the tepid waters of equatorial currents would freely circulate. The general humidity of the atmosphere would far exceed that of the present period, for increased heat would promote evaporation in all parts of the globe. The winds would be first heated in their passage over the tropical plains, and would then gather moisture from the surface of the deep, till, charged with vapor, they arrived at extreme northern and southern regions, and there, encountering a cooler atmosphere, discharged their burden in warm rain. If, during the long night of a polar winter, the snows should whiten the summits of some Arctic islands, they would be dissolved as rapidly by the returning sun as are the snows of Etna by the blasts of the Sirocco. We learn from those who have studied the geographical distribution of plants that in very low latitudes at present the vegetation of small islands remote from continents has a peculiar character. The ferns and allied families in particular bearing a great proportion to the total number of other plants. Other circumstances being the same, the more remote the isles are from the continents, the greater does this proportion become. Thus, in the continent of India and the tropical parts of New Holland, the proportion of ferns to the phanerogamous plants is only as 1 to 26, whereas in the South Sea Islands it is as 1 to 4, or even as 1 to 3. We might expect, therefore, in the summer of the "great year," or cycle of climate, that there would be a predominance of tree ferns and plants allied to genera now called tropical, in the islands of the wide ocean, while many forms now confined to the Arctic and temperate regions, or only found near the equator on the summit of the loftiest mountains, would almost disappear from the earth. Then might those genera of animals return, of which the memorials are preserved in the ancient rocks of our continents. The pterodactyl might flit again through the air, the huge iguanodon reappear in the woods, and the ichthyosaurs swarm once more in the sea. Coral reefs might be prolonged again beyond the Arctic Circle where the whale and the narwhal now abound, and droves of turtles might begin again to wander through regions now tenanted by the walrus and the seal. But not to indulge too far in these speculations, I may observe in conclusion that however great during the lapse of ages may be the vicissitudes of temperature in every zone, it accords with this theory that the general climate should not experience any sensible change in the course of a few thousand years, because that period is insufficient to affect the leading features of the physical geography of the globe. Notwithstanding the apparent uncertainty of the seasons, it is found that the mean temperature of particular localities is very constant when observations made for a sufficient series of years are compared. Yet there must be exceptions to this rule, and even the labors of man have, by the drainage of lakes and marshes and the felling of extensive forests, caused such changes in the atmosphere as greatly to raise our conception of the more important influence of those forces to which, in certain latitudes, even the existence of land or water, hill or valley, lake or sea must be ascribed. If we possessed accurate information on the amount of local fluctuation in climate in the course of 20 centuries, it would often undoubtedly be considerable. Certain tracts, for example, on the coast of Holland and of England consisted of cultivated land in the time of the Romans, which the sea, by gradual encroachments, has at length occupied. Here, at least, a slight alteration has been effected, for neither the distribution of heat in the different seasons nor the mean annual temperature of the atmosphere investing the sea is precisely the same as that which rests upon the land. In these countries, also, where earthquakes and volcanoes are in full activity, a much shorter period may produce a sensible variation. The climate of the great tableland of Malpais in Mexico must differ materially from that which prevailed before the middle of the last century, for since that time 6 mountains, the highest of them rising 1,600 feet above the plateau, have been thrown up by volcanic eruptions. It is by the repetition of an indefinite number of such local revolutions, and by slow movements extending simultaneously over wider areas, as will be afterwards shown, that a general change of climate may finally be brought about.